Hello, Clarice.
Morning.
Good morning, Brian.
Hi.
Clarice. Okay, perfect. You can hear me. Okay, perfect.
Yep.
If you want, you can try actually, because you are the first one. You can try to see that.
Is Tanjim here? I think Tanjim's here. Oh, no?
Okay, perfect. Great. Hello, Tanjim. No, I cannot see. Okay, let me see.
Okay, never mind.
No, he's not here. I cannot see him. If you want to share the.
Tanjim will start sharing the his screen.
Okay,
first.
perfect.
Right.
Sure.
So just gonna wait for him to come.
Perfect. How are you, Brian?
I'm doing well. Yourself?
Good, very good. How's it going?
Yeah. Anxious for COVID to get over.
Yeah, I totally agree.
So we come back to the office and talk to somebody.
I agree. I agree.
But it's easy to do this from home. So
Not really, honestly. I prefer to teach in class rather than online. But anyway.
oh yeah, sure. Yeah, that's true. Well, let's see. I'll go into mute.
Hello, Tanjim.
Hi, Shervin. Hi, Kelly.
Okay,
Good morning,
very
Tanjim.
Good morning.
Morning.
Tanjim, if you want, you can start sharing your slides to see if it's working correctly.
Perfect.
And just a question, if you and Clarice both are going to present, how do you want me to announce the time?
Announce the time?
Yes.
Yeah.
How many?
So we'll do that internally so typically, I guess you would give a 10 minutes notice, and Clarice will take over by then. Anyway.
Okay, so Clarice will have only 10 minutes, right?
Sorry?
You want me to announce the time at 35 minutes and Clarice will have only 10 minutes left?
Yeah.
For her.
Yeah.
Okay.
She would take over well before that. So she'll take over halfway through.
Okay. And can you just move the slides, go to the next slide to see if it's working correctly, because sometimes it's stuck on the first slide.
Oh, okay.
Yes.
I don't think I need to be present. Atta has everything under control. Thank you so much.
Is it moving or?
No, it's still on the first one. Can you move again?
Yeah. So just give me a second.
Yes.
There we go.
Right. Hi, Yesim.
Hi, Tanjim. I want to encourage everyone who feels comfortable to turn on their videos so that the presenters can have faces to talk to.
Okay, it's time. We can start, Tanjim.
All right, let's start. First, I would like to thank the organizers for having this paper and this conference. Unfortunately, we are not in Dallas, but hopefully next year we'll be. My name is Tanjim Hossain, and this is joint work with Andrew Ching, Shervin Tehrani, and Clarice Zhao, who will be taking over the second part of the presentation. So, in everyday life, we frequently make decisions in environments or contexts with uncertain outcomes. Uncertain outcomes, the uncertainty can be about product quality or my inherent preference for the product, returns from an asset, value of a house, weather outcome, or even political outcomes. And typically, we receive information about some information about this uncertain outcome. Could be from word of mouth, past experience. I get reviews of users of a hotel. I may have used the product myself in the past. We may receive information from experts such as stock analysts, real estate agents, or weather forecasters, and so on. So the question is, how do we learn from the information received and update our beliefs? That is a central question in marketing and economics. Now, in structural empirical learning models, which is quite common in marketing, researchers typically observe choice behavior, but not consumers' actual beliefs. As a result, they need to assume some structure in the belief updating rule. Most common one is Bayesian learning because of its parsimonious nature. But if this belief updating rule is misspecified, that may lead to biased estimates of preferences and preference parameters and misleading counterfactual predictions. Also, a lot of times on most of these models, people look mostly at mean, but in terms of belief updating, when people are risk averse, posterior variance updating is very important in terms of predicting choice behavior. Large chunk of the literature assume that people are homogeneous in terms of belief updating. There are one or two papers that allow for heterogeneous belief updating rules, but not that many. But people may actually vary in their belief updating rule. My belief updating rule may be a bit different from Shervin's. And also, even within one person, my belief updating rule may vary over time as I receive more information. So in this paper, we investigate how people learn about an uncertain outcome and or update their beliefs using laboratory experiments. So in terms of laboratory experiments, mostly in experimental economics, there is actually large literature about beliefs. But this literature mostly ignore belief variance, heterogeneity across subjects, or sometimes I'll say subjects, sometimes I'll say consumers, and also dynamic updating of belief updating rules. So most of these papers, especially the older papers, but even current papers, use binary variables with binary outcome. So that's very common in experimental economics, especially. So one issue with that is that variance can not even be separated from mean. The mean basically determines variance. Most of this paper look at only static setting where all the information is received once, or at least the belief is elicited only once. One exception is goods, but he looks at 2 periods, but does not allow for heterogeneity. Gamal and Greter does allow for heterogeneity across agents, but in a static setting. There are a couple of more recent papers in experimental economics / marketing. Hossain and Kui collect belief data in a static setting but with a number of signals from different sources of information. And there the goal is to look at how say correlation across sources, how that affects belief updating rule. But and they and the next paper, Jindal and Ariberg, use a mechanism to like elicit beliefs that is incentive compatible even when subjects are not risk neutral. The same method we use in this paper too. But Hossain and Roque do not directly elicit variance, rather figured that out from the means, or doesn't consider consumer heterogeneity. Jindal and Ariberg recently accepted paper, very nice paper. They collect belief data in the context of price search. They do not study heterogeneity in terms of updating rule or dynamic changes in the updating rule.
Can I ask a quick question?
Absolutely.
When you say belief variance, are we talking about the risk attitude being different? Or
no,
okay.
No. Rather, you suppose you know that the rather no, it's not a risk attitude being different, but how. Let's take a very simple example. You want to know the likelihood of rain raining in the afternoon, and you had a prior that it's 50% chance. Then somebody comes along and says it's 80% chance. So from there, you would form your own belief, right? You might say that, okay, this guy thinks 80%. My prior was 50%. I think it's 70%.
I got it. Got it.
So basically, that's how do we do that? Okay, good. So what do we? Thanks, Ti. Do in this paper? So we have 3 research questions. How do people update their belief distribution? How they differ. Second one is how they differ from each other. So are they heterogeneous or more or less homogeneous? And do they change their updating rule dynamically? And if so, how? And what do? We collect belief data in an incentive compatible way in a dynamic learning environment where the prior distribution is well defined and the signal structure, the information that I receive, is well defined. They receive information multiple times and we elicit their beliefs multiple times. And we try to present that in a natural and relatable context to help subjects engage. And I'll talk about the context quite a bit soon. We collect belief data both in terms of first and second moments of the distribution. That addresses question 1. We have a pretty rich data set that allows for heterogeneity across subjects. That addresses question 2. And also, they receive signals many times. So it's a dynamic environment where we allow their belief updating rule to change over time. That addresses question 3. Quickly, our main findings. We do find that people are heterogeneous in their belief updating rules. That means that we can divide them in different types in terms of their belief updating rules. And specifically, we divide them in 5 types. The belief updating rules do significantly deviate from Bayesian updating rule. So, and our subjects are heterogeneous. So some are, say, more conservative than Bayesian updating rule or more overreactive than Bayesian updating rule. What that specifically means, we'll get to that later. But more importantly, when I said some are more conservative, some are more overreactive, that was slightly imprecise because their belief updating rule actually change over time. So specifically, posterior means become more reactive over time, and their posterior variance updating rule also changes, basically, and they become more certain relative to Bayesian over time. Not only they become more certain over time because they are getting more information, but their like marginal effect of getting more signal in terms of reducing their variance, it actually becomes more effective than in terms of reducing their posterior variance than what Bayesian model would predict. Finally, when they face a surprising signal, they actually take it more seriously than they take a non-surprising signal. Specifically, they overreact more in updating their posterior mean, and they also become significantly less certain about their posterior mean. So these are our main findings. So I'll move on to the experimental design. Before I move on, any questions? Right. So suppose you're walking around in a neighborhood and you are that has nice houses. You're curious about the house prices, and then you learn that in this neighborhood, house prices are around $800,000. And you learn a bit about the variance too. That is your prior distribution or prior knowledge about the house prices in this neighborhood. Then you see actually a house in the neighborhood, and you're curious what the price, selling price, or sometimes we'll call the value of this house will be. So you see some person on the street who lives in the neighborhood, so knows the neighborhood prices a bit better, and you ask her, what do you think the selling price of this house for sale would be? And she says $850,000. And then you say that, okay, and what do you think about the variances, or what do you think the chance that, so you say it will sell for 850, but of course it may sell at slightly different price. What do you think the chance of it selling within 825 and $875,000 is? And she says 40% or 60%. So this gives you a signal. From there, you form your own belief. So you know the prior is 800, and the first estimate you got, or first signal you got, says 850. So you think that, okay, maybe my guess is it will fall around 840. And so that will be your best guess or your posterior mean. So we basically do this exercise, and we ask you, okay, you got this signal, what is your posterior mean, or what is best guess of the house price? Let's call it GT. And you say 840, and then I say that, okay, what's the probability that the true price would actually fall between 840 plus minus 25, say 865 and 815, and you say 30%, some number. That I call certainty level, and I pay you once we see the actual outcome using the binary scoring rule by Hossain and Shahrokhi 2013. So that's the main exercise. Basically, you start with a prior, then you receive a signal, which is some expert or some person on the street, but who knows about the neighborhood more. That tells you the her guess about the specific price, the selling price of a specific house. From there, we elicit your posterior G1, H1, and we do that repeatedly. So there are then you move on and see another person and ask that person what they think the selling price would be, and they give you their estimate, E2, and so on. And we do that for for a given house. We get estimates for 7 persons, say 7 experts, and every time we ask you, okay, you got these signals, and you have all the signals and your prior, and what is your current best guess and current certainty level. That's what we do. And this gives us both posterior mean, the best guess, G1, G2, up to G7 after every signal we receive. Also gives us posterior variance, not directly, but indirectly through this certainty level. Why do we elicit, we want to elicit variance, but we elicit it indirectly using certainty level. So why? So consumer learning literature implicitly assume that posterior variance is perfectly understood, and experimental economics literature or the lab experiments, they don't really elicit posterior variance, at least not in an incentive compatible way. A big reason for that is that to be incentive compatible, if you want to directly elicit variance, you actually require multiple realizations from the same distribution. In our context, that means that the same house has to have two selling price at the same time, which is not really feasible in our context. Also, the scoring rule would become quite complicated, and subjects may not comprehend. Also, overall, we actually ran a lot of pilot, and one thing, it seemed that people don't really think in terms of variance. Rather, they think in terms of the likelihood of their guesses not like falling within a range. So that's why we came up with this certainty equivalence idea. And we did, so there is one-to-one mapping between certainty equivalence and, sorry, not certainty equivalence, my bad, certainty level and variance. And we even thought about that we translated directly to for subjects to report their variance, and then we'll translate it to certainty level. But that didn't, we ran a lot of pilots that didn't work so well because we found that people really think about probabilities instead of direct variance. So what they report, we ask them to report. We ask them to report, or we elicit their best guess, which is the posterior mean. Then we ask them how certain they are about the best guess. So this we call certainty level, and basically that's the probability that the true value will fall within 25 units of their best guess. So if they say their best guess is 84, they report to us what their probability that the true value will fall between 815 and 865. So how do we explain this? Yeah.
Sorry, I have a clarification question. Does it matter that the belief that is being elicited is for a particular house versus the distribution of prices in the neighborhood?
No, but in terms, no, that's how we explain, because it just seemed more natural thinking about one house. And then we actually have 12 houses, so it just seemed more natural that way. So, and how did we exactly explain to subjects? So this is from a slide in our instruction video. So basically they're told that this house is up for sale. This is the neighborhood price. Then you see a person, this woman from Simpsons. No, it's not Simpsons, it's Family Guy probably. Anyway, my knowledge of pop culture is not exemplary. Anyway, so she tells that her best guess is E1, and she thinks that the true price will fall within E1 minus n plus 25 with this percentage. That's her certainty level. And then from there, subjects will have to come up with their best guess and their certainty level. And they have to report this to us. So basically they see, this was an illustration that this is prior neighborhood price is 170 and certainty level is 138, which means standard deviation is 50. This estimate of the first person is 209. Standard deviation is 30. So we say associated certainty level is 60. From there, they have to tell us best guess. Suppose this person says 199. Then we say, okay, great. So what's the likelihood that the true value falls within 224 and 201? And they have to report that certainty level. And they do, yeah. please.
So pegging onto Pranav's question, I think where it's coming from is that if you're asking the mean of the neighborhood, then you can assume kind of normal distribution. But if it's individual house, then you cannot assume that distribution would be normal. That's I might be wrong, but you know what I mean?
I think I know what you mean, but like the trade-off is what is easier for them to understand.
Right. Yeah.
And we kind of say that, okay, look, these are all normally distributed. They knew how normal distribution works and so on. So I think I see what you mean, but there is a trade-off of how to explain. And this is very not super easy to explain. So we actually worked quite a bit in figuring that out. So, but I take your point. Thanks, CA. So, and they see 7 periods. So these are again from all the slides. So how are they going to get paid? Again, we use the binary scoring rule. So how are they paid? Suppose in a period, a subject reports best guess G and G, and at the end, the true house price becomes S. So then for that period, they're assigned a score of GT minus S squared. Basically, it's squared error. Then we randomly draw a number K from uniform distribution from 0 to 5,000. If this K is greater than the score, the subject earns a reward. Otherwise, there is no reward. So basically, then the subject's goal is to maximize the probability of getting the reward, independent of whether they're risk averse, risk neutral, or even risk seeking. Then we can actually show that it's optimal for them is to just report their beliefs truthfully. And this method has been used in quite a few papers. So we, as is nowadays common, we actually told the subject that it is optimal for them to report their beliefs truthfully based on this scoring rule. For certainty level, the scoring rule became even simpler. The score would be basically 1 if the true value falls within GT best guess minus n plus 25 minus the reported certainty level squared. And if the best guess does not fall within that range, it will be just certainty level squared. And K is drawn from the uniform distribution on 0 to 1. So what was the procedure? We ran this experiment in Teal, the Toronto Experimental Econ Lab, programmed in Z3. So first they came in and took a cognitive reflection test with 3 questions, same 3 questions that Pradeep talked about in his presentation yesterday. Then they read through a handout on statistical concepts, which describe normal distribution, mean, median, and so on. They actually had access to this handout already when they registered. And when they came, we sat them down for at least 8 minutes. So they had to read it for 8 minutes. And we also took subjects who had taken some statistics in high school or college. So these concepts were not completely new to them. Then they watched the experimental instructions video, part of which you saw, and then they took a comprehension test to ensure that they understood the setup. And if they passed the comprehension test, then they moved on to the actual experiment. If they didn't pass the comprehension test, which was around 15%, I think, or 10 to 15% of the subjects who came in, then we just paid them for their time and they left. In the main experiments, there were 4 practice houses and 8 paid houses. Each house had 7 signals or periods. Then we elicited their risk attitude using Holt-and-Lowry method. Then they answered a quick questionnaire. Then we paid. So they're paid for these 8 paid houses, but for each house, there were 7 periods. We chose 1 period to pay randomly to pay for the best guess, another period to pay for the certainty level. Okay. And finally, the parameters that we chose, all the houses. So we changed the initial prior. The true house price was drawn from a normal distribution in all cases, but the mean were of the neighborhood price was between 670 and 940. We chose 4 different ones so that they don't think it's the same house or the houses are not independent. And we kept the standard deviation of the neighborhood price at 110, which corresponds to certainty level of 18%. The signals, there were 7 signals and for a given house, and all signals, like all the experts or people on the street they meet, had the same signal precision. So the signal error term had the same variance or standard deviation of 50 to 50 or 80, and so corresponding certainty level were 25% to or 38%. So within a house, all the 7 experts had the same precision level, but across 2 houses, the precision level could be different, either low, so certainty level of 25, or high, certainty level of 38. And we call them high or low, but it doesn't mean much. It's just we didn't want to use just one certainty level, just as robustness check, we have 2 values. Now Clarice will take over and will describe the empirical section.
Thank you, Tanjim. So for the next 20 minutes, I will go over the empirical analysis and the results. Our final data includes 104 students from University of Toronto, with 40 of them being male, 64 female, and the average age is about 20.5. As Tanjim has explained, for each individual, we observe the input for 8 houses, and for each house, we have 7 signals, and they will receive them one by one. We will use subscript I for individual, J for house, and T for period for now. Variable E0 is the initial prior mean, which is the neighborhood average house price, and the ET is the value of each signal they receive. Sigma 0 is the initial prior standard deviation, which translates to H0, the initial prior certainty level. And similarly, we have sigma epsilon for the signal standard deviation and the corresponding certainty level H epsilon. So far, these variables are given by the experimental design. And the main variable that we collected from the subjects are the reported best guess G IJT and their reported certainty level H IJT. These 2 variables describe the posterior belief at period T, which is also used as a prior belief for period T+1. Let's quickly go over the standard Bayesian learning model based on Orhun and King 1996 paper. This is the posterior mean updating equation. Essentially, the posterior mean should be a weighted average of prior mean and signal, where the weights sum up to 1 and are determined by the variances. We can rewrite this posterior mean equation GT as a sum of the prior mean GT minus 1 and this ratio times the difference between signal and prior mean. So this ratio basically is the weight on the signal. This new expression is convenient to us since we have a nice linear formula of GT with 2 components. As for the variance updating, Bayesian model gives a predetermined evolution of posterior variance. Based on our definition of certainty level, it has a 1-to-1 mapping with the variance. So we know that certainty level also will follow a predetermined path on the Bayesian model. And we have the equation expressed here. So motivated by the Bayesian model, we come up with the empirical specifications. We define X as the difference between signal and prior. So first of all, the Bayesian formula is nested in this equation. If a subject is Bayesian, then we will have alpha equal to 0, rho equal to 1, beta will equal to the Bayesian weight of each signal, and gamma will equal to 0. The weight assigned on the signal should be the effect of X on G, so which give us this term here, beta T plus gamma G times the absolute value of X. This weight should be, first of all, period specific, because if someone is Bayesian, then beta T will be equal to the ratio of tau epsilon to the sum of tau 0 and t times tau epsilon. So this ratio obviously is t dependent. And as t gets greater, the weight should become smaller. In addition, we want to investigate whether when somebody receives a surprising signal, which is a signal that's really far away from your prior, how do they react? Do they tend to assign more or less weight on this type of signal? So we measure the surprising element using the distance between the signal and prior. So here it will be simply the absolute value of x. And gamma g will indicate whether the signal whether the weight on the signal is affected by the surprise element or not. Next, we will talk about the empirical specification for certainty updating rule. So we are interested in two key questions here. First, in Basin updating model, certainty level should follow a predetermined pattern. We would know precisely by how much one should increase that certainty level in each period. So empirically, we want the data to tell us how exactly subjects change their certainty level over time. Do they follow the same pattern as Bayesian predictions? So with this empirical setup here, we calculate the marginal increase of certainty level after receiving a signal, which is expressed right here. And we can then compare that value with the Bayesian model prediction. Obviously, this marginal impact of a signal should be period specific again. And another important question we have is, does signal affect certainty level at all? So back to, I kept saying this, in a Bayesian model, certainty level is predetermined based on the variances. So certainty level will always increase over time, regardless the signal value. This is often a common critique of Bayesian learning model. So just imagine you have received a couple signals, and now you form your belief around 500. But suddenly the next signal you get is at the value of 800, which is really far away from your prior. So how would that make you feel in terms of uncertainty? This is why in the equation, we decided to include the surprise element again. And so for example, if we find a negative value of gamma h here, that will indicate people report a lower sensitivity level when receiving a more surprising signal. Okay, so we will use finite mixture model to incorporate potential heterogeneity among the individuals. Specifically, each type is associated with a posterior mean and a posterior certainty updating rule. We allow the parameters in the updating rule to vary across types, but we do fix the arrow turn distribution across types. An individual is assumed to be the same type within the whole in the whole session of the experiment. And I have listed here the likelihood functions we use for the finite mixture model. At observation level, the likelihood conditional on the being type K is the product of likelihood from equation G and then equation H. At individual level, sorry. Yeah.
Let me ask you a question, clarify a question. So what is the parameter that summarizes individual level heterogeneity here?
The parameter that summarizes
or something, anything, right? What is the key element of this model that summarizes the individual level heterogeneity?
So if we go back here, basically I'm saying that we are allowing all this parameter to vary across types. So the rho h, alpha t, gamma h, and so is.
The question I'm asking is if there is anything like for example, in the context of linear fixed effect regression, there is an alpha I thing, right? So is there anything like that in this model that captures the individual level heterogeneity, that summarizes? I just don't see the notational equation, right out of the slide, so I'm just asking.
Yeah. So my apology that my slide actually simplified the equation we actually use in the paper. So maybe I'll talk to you like afterwards to show you the exact equations I have in the paper. For the presentation reason, I simplified a lot of the notation just so that I can go over them a little quicker. But
okay, that's fine. Yeah.
So,
right. My follow-up question would have been that, like, what is the identifying variation of that heterogeneity itself? Is it out of functional form, or is it identified like out of some other variation? That was my follow-up question. That would have been.
Okay, the identification, I think it comes from the data variation because we do observe very detailed variation at individual level. And then, so we feed them, we put individual in the same environment, right? And then they give us different G and H. So these are what the different, the variation that comes from. Mm-hmm.
Right. Just a quick question. So I think if you have a finite mixture model, you just have subpopulation. So the individual heterogeneity is really just coming from the fact that each individual has a different history, but all individuals of the same types are still behaving the same way, conditional on their individual history. Is that right?
The individual depends on their history.
Model. Right, but the mixture model is a different type of heterogeneity. It's not each individual is his own type. Each individual becomes part of a subpopulation.
Yes,
it's just that they have a different history.
Exactly why I asked the question. Well, at what level the heterogeneity is kind of captured, and what is the notation, exactly notation of right? Exactly the notation of the individual that captures the individual heterogeneity.
Sorry for interrupting, Clarice. You have 10 minutes.
Oh.
And if I may just jump in, I think when Clarice present the table of result, that might clarify it. So I suggest we just postpone it, the question, and then when you get to the table, if you still have questions, we're happy to answer.
Mm-hmm. All right, I guess I'll jump through the likelihood function part. Just know that the individual type is based on a person's whole history, rather than a single observation. And then we estimate using EM algorithm. So in total, we estimate 7 models with the number of types varying from 1 to 7. And the table here presents the likelihood and BIC of these models. So we find that allowing heterogeneity significantly improve the model fit, and that the optimal number of types is based on BIC is 5. So this leads us to the first finding: subjects are heterogeneous in the belief updating rule. So here is the table Andrew was talking about. So we actually estimate all the parameters among 5 types. And then this is a lot of estimates to go over, but one simple thing I want to talk about based on the table here is in the last column of the table, we have listed what the Bayesian estimates should be. And then we compare the estimate of each type to the Bayesian estimates and find out none of these types is exactly the same as Bayesian. Obviously, some estimates, they will be close enough to Bayesian, but throughout the history, they are not exactly Bayesian. So this give us the second result. Subject belief updating rule, regardless of their type, are significantly deviated from Bayesian updating rule. So now we'll first look at the results based on the posterior mean update.
Okay, so there seems to be like a couple types, 5 or 4 or 5, right?
Yeah.
I might have missed the part, but how are those types identified? What are the criteria for that?
How are these types identified? What's the criteria for that?
Right. Yeah, I might have missed a very basic thing.
Okay. So this, what I'm saying is the algorithm tell me they are identify the 5 types, and then for each type probability, they spits out. So like you said, 4 and 5 here, they have very small probability. So actually, my next point was going to say that, well, type 4 and 5, they are really small. They are about 5% each in the population. And we believe that this is commonly seen in the lab because in the lab, sometimes you get subjects that act a little bit different from the rest of the group. And our EIM algorithm is actually able to capture this small variation. We believe these two types are not representative of the population. And so later on, I'm not going to discuss what the type 4 and 5 are like, mostly focus on type 1, 2, 3. But maybe given the time constraint, I have like 5 minutes left. I'll just go over the results and then talk to you in person later on about the technical part. Is that okay?
Okay.
Yeah. So 2 classes of deviation from Bayesian model that was explained by Tanjim before. We have overreactive and conservative. So in general, overreactive is just people who assign too much weight on the signal, while conservatives are people who assign too little weight on the signal. So in our results, we see that for the 3 types, we plot how much weight they are assigning on these signals over period. So one main finding is that individuals type actually vary over period, because if you look at here, for type 2, for example, at the first 2 periods, they appear to be assigning low weight. Oh, sorry, the blue curve is the Bayesian curve, and then the orange one will be the exact weight they assign on the signal. So the blue curve is higher than the Bayesian. So people are actually being conservative here for type 2. But in the later period, they tend to become Bayesian. For, say, type 3 here, in the beginning, they are Bayesian. But in period 5 and 6, they become more overreactive. So this is an interesting finding we have here. Relatively, they are assigning more weight on the signal compared to Bayesian over time. So in the certainty level updating rule, we plot the marginal increase of certainty level after each period receiving a signal. So the Bayesian model will predict that the blue curve here, that this additional increase should gradually become small and smaller over time. But what we see here, people tend to increase either a constant extra certainty level over period, or they increase a lot in the first period. And then later on, the marginal increase tend to be relatively constant. So this is our second result, saying individual posterior certainty level updating rule has relatively a constant marginal change over time. And then if you combine the results 3 and 4 together, we will say that this seems to suggest later signals are treated by the subjects more seriously than what Bayesian model would suggest. So let me see, I have 2 minutes left. Here, I'm going to talk about the surprising signal. So for all the 3 types we have, their estimates for gamma G and gamma H are both significant. Gamma G is positive.
Clarice, Song actually kindly donated 5 minutes from his time.
Oh,
so
great.
You have
Thank you so much.
Yeah, you can take 5 minutes out of my time.
Appreciate it. So as I said, gamma G is positive and significant. Gamma H is negative and significant. So that means that overall, we see people are overreacting to surprising signals. When they see a signal that's far away from their prior, they tend to put higher weight on that kind of signal. And then when they receive a signal that's surprising, they tend to lower their certainty level. Basically, they feel like, oh, I'm not sure about my previous guess anymore. Maybe I was a bit wrong. Maybe I should think again about my best guess. So this is what we are observing here. And then there is a bit of a heterogeneity among the 3 types, even though the direction is the same. Type 1 tend to be the least sensitive to surprising signal, and type 2 and 3 are more similar in terms of the mean part. In the certainty part, type 2 is a bit more sensitive. So here is a quick summary table for the findings we have here. So among the 3 types, we find that in terms of posterior mean updating rule changing, we see type 1 change from conservatism early on, to Bayesian later on, and then sometimes depend on which how big the signal precision is. Sometimes they may even go to overreaction. For type 2, they change from conservatism to Bayesian, and for type 3, they change from Bayesian to overreaction. In terms of the marginal increase, type 1 is usually pretty flat in terms of certainty level marginal increase. The type 2 and 3, they have a big jump in the first period, and then later on relatively flat. In terms of surprising signal, they have all these are all positive in the mean updating rule, and these are all negative in the certainty updating rule. So they're pretty consistent with different magnitudes. And then lastly, we ran a quick type analysis. Basically, we want to see how does individual characteristics correlate with the updating rules. So first, we see no significant effect for risk attitude and gender. So among the 5 types we observe, these 2 doesn't really play a role. What really significant is the cognitive reflectiveness score. So whether someone is system 1 or system 2 in some sense. So we find that if someone is system 1, then they are more likely to be type 3, 4, or 5. While someone is system 2, then they're more likely to be type 1 and 2. Great. I think I'm just gonna conclude my presentation here. We designed a lab experiment to track people's belief formation after receiving information. We come up with incentive aligned design to elicit variance and also, in other words, uncertainty with individual. We are also the first to study learning in a dynamic environment under normal distribution assumption. Our data suggests that people deviate from Bayesian updating rule, and there's heterogeneity in their updating rules. In particular, posterior mean updating rule change over time. For posterior certainty updating rule, we find that constant marginal increase over time, except for period 1 in some occasions. And we studied the response to surprising signal. It seems that people are more reactive to surprising signals in mean updating rule, and then they lower their certainty level after receiving surprising signal. So that'll be all, and I will stop right here. Thank you very much. And I'll respond some question later on after, and I'll give the mic to discussant right now.
Okay, can everyone hear me?
Yes.
Okay, so see the slides?
Yes.
Okay, great. Let me check if it works. All right. Okay, so first let me thank the organizer for having me to discuss this very interesting paper. My name is Song Lin from Hong Kong University of Science and Technology. Overall, I think this is very, very interesting, very nice work, and with a lot of potentials. Okay, it's already very well-written paper. So my job today is quite simple. So I try to summarize the paper, what's going on in the paper, using a little bit of my own language here. And along the way, I will offer some comments, my own 2 cents, and hopefully this can add something useful to the paper. And what I really like about the paper is it goes after a very big question, very fundamental questions. So how do people form or update beliefs? And I think I don't really need to give any additional example to convince you that this is a very important problem. And it's the foundation of information economics, in game theory, in decision making. We also rely on this framework. And the paper has a very nice lab experiment, very well designed, with 3 very important features here. One is it tries to focus on the belief formation of a continuous random variable. Okay, And this also leads to the need to measure consumers or the subjects, posterior variance, or they call it the certainty level, okay? Or the at least they are one-to-one correspondence. And another key feature here is that in the experiment, they try to measure the beliefs, how they change over time. Okay, so all these three together, they are quite unique. Okay, although we have seen a lot of work in this area, but this is perhaps the first study to combine all these three important features in one single study. So I think this is a very nice contribution. And in terms of findings, there are some very interesting findings. Let me summarize three of them. So one is there is some deviation, substantial deviation from Bayesian learning. Okay, that's a very important finding. And the second important finding from the paper is there are some heterogeneous updating rules, okay, adopted by different types of people. Okay, and finally, what I find interesting is people tend to become more reactive to those new signals over time. Okay, so these are the interesting findings. I think it's quite worth highlighting. So here, let me give you a very quick recap of what's going on in the experiment. So basically, the key setup of the experiment is that there's a bunch of subjects. They're university students. They recruited to a lab. They're asked to evaluate a house. Okay, so how much the house should be selling, and they are told that there is one underlying true value, and this is coming from some prior distribution. Okay, and they are communicating well what the prior is and what the variance is, assuming that this is a normal distribution. And in each period, there are 7 periods, okay, in total. And in each period, the subjects are going to receive IID signal. Okay, and this signal is going to depend on a true value plus some noise, and the noise is normally distributed. And after they have seen these signals, they are going to give a guess about the true value of the house. And at the same time, they're also asked to report their certainty level. And this certainty level is defined as the probability of the true value falling into some neighborhood of the guess. I think this is a very nice innovation in the paper. So instead of using the more traditional but hard to intuit concept, the variance, posterior variance, they use a different concept, which is equivalent. And the experiment also has a very nice incentive scheme, which follows a very nice work by one of the co-authors, Hossain here. It's published in 2013 in Review of Economic Studies. And all the subjects, they are going to go through all the signals, all these exercise, and they're going to repeat the same exercise for 12 times for different houses. Okay, so that's basically where the data come from. Okay, so given these data, they're going to analyze how or whether the subject's belief updating would systematically deviate from the Basin benchmark. Okay, so what we are going to do is, I say we, but I'm not in the paper, but what they are going to do is to take the familiar Bayesian updating formula, okay, and then convert it to a formula that is more convenient to analyze. And so in this formula, the key parameter is this term, this theta term. Okay, so this theta term captures the Bayesian benchmark of updating. Okay, and in addition, there is also a measure of the distance between the signal and the prior mean. Okay, so this is coming from the data. So the idea of the empirical test is trying to use the belief data and back out some estimate of the theta and see how it deviates from the Bayesian benchmark. Okay, so that's how basically how it works. And to do that, they have specified an econometric model, okay? So which assumes the Bayesian benchmark as a special case, so that they can look at, okay, whether empirically, whether the subjects are really deviate from the benchmark. And what's nice thing here is that they include the surprise effect, okay, captured by the absolute difference, the absolute distance between signal and prior mean. And the model for the certainty level is similar. So they first take the Bayesian benchmark, which is the built on the posterior variance, and then convert those variances into certainty level, and then they have a mapping from the certainty level of the previous period, as well as the certainty level for the noise, and convert it to the certainty level for the current period. Okay, and then they use the belief data to recover this function, F function, and see how it deviates from the Bayesian benchmark. Okay, so that's how basically how it works. So let me offer a comment here. So the paper used a Bayesian benchmark by defining the parameter theta in this way, okay, which is a function of the precisions of the prior and the noise, as well as a function of the number of periods. And this already assumes the evolution of the precisions over time. Okay. Now, in the Bayesian work, okay, so it's very elegant that there are several expressions for which are equivalent in theory. Okay, so you can also express the updating rule in a slightly different way, but instead of building on the prior precision, you can build on the precision in the previous period. Okay, this is one approach. Now, the empirical text will be slightly different because now we have to look at the data for each period. Okay, look at the precision in the previous period and use those data to test the certain level for the posterior mean for the current period. Okay. Now, I think this is relatively more conservative because we are trying to test whether subjects are deviating from the Bayesian rule in one single period instead of the entire multiple periods. Okay. And another way to express the Bayesian rule is to use the information of the average of the signals. Okay, so this is also another familiar for formula for the Bayesian updating rule. So we take the sample average or the average of the signals as well as the prior. Now note that there is a reminder in the experiment that what's the average of the signals is in each period. Okay, so we actually remind the subjects that. So this information is a very salient information to the subject. So presumably it's quite natural for them to take these statistics, these sufficient statistics, and do a weighted average, okay, with the prior. So that's likely what they do. So it will be interesting to look at this approach, so trying to test this formula directly. And I'm not sure whether this would lead to a different results, but I think at least it could be a very good robustness check to see how the results, whether the results can go through different econometrics approach. Okay, so that's my first comment here. And a related issue here is that for the testing.
You have 1 minute left.
Okay, no problem. Okay, so a related problem here is that when we test the posterior certainty level, the function, the Bayesian updating function is actually nonlinear, but in the econometric model, the specification is linear. So it would better you can try the nonlinear specification here. And also because you are measuring the posterior variance and the posterior mean, these two measurements could be correlated. So it'd be good to control this correlation. Okay, something you can do. Okay, so in terms of the result, I don't have time to repeat all these this result here. So I would just like to point out number 3 and number 4. Okay, result 3 and result 4 together. So it's kind of intriguing, right? Why do subjects they become more reactive in their posterior mean, but less reactive in posterior certainty level? Okay, so I think it'd be nice to provide more results about the mechanism behind it. Is it because of some sort of order effect or recency effect, such as people may tend to ignore earlier signals instead they focus on more recent signals? Okay, and this result may be inconsistent with some earlier results in the literature, like the confirmation bias. Okay, so what they found is that people may tend to misinterpret some ambiguous evidence as confirming to their prior belief, or they may pay just less attention to the new evidence if they feel they're confident about their belief. Okay, so these are potentially inconsistent with the result in the paper, but I think given the model is capable of capturing the heterogeneity, it will be interesting to look at whether there's a type of consumers following this bias and trying to reconcile these two different departures of Bayesian learning. Okay, and this I think can be easily done by modifying, adjusting the model, okay, in some way. For example, you can test the posterior mean as a function of the precisions, okay, in the previous period. Okay, so it's something that you can do. Okay, so I'm run out of time here. One last comment is kind of trivial. So you can include some information about the statistical sophistication that you have already measured in the experiment, and trying to test whether this can explain your empirical findings. So once again, it's a very nice paper, very interesting. I wish you all the luck, best luck with the work, and thank you for having me again.
Thank you, Sung. We can move on to the next presentation. Michelle, if you are here, please share your slides.
Sorry, I am here. It's asking me to do a permission thing.
I can try to make you an attendee to see if it works or not. Is sharing working or not?
Yeah, sorry, I just got back in. And hold on 1 second. Should work now, but let's get it to the right. I was just cycling on, so maybe we gotta.
Yes, I can see your screen right now.
You can see it?
Yes.
Oh, okay. Do you see the presentation in the screen?
Yes.
All right, Okay. All right, so it looks okay now?
Yes.
Great. Okay, so actually last night to try this out to make sure it was working, but didn't solve all So thank you to the committee for having me here to present this paper, and thank you to my discussant Nitin for in advance for the comments. So this project is a project with my colleagues Yufeng Huang and Paul Ellickson, both at Simon with me, Mitch Lovett. This is about learning to set prices, and much like the previous paper that was talking about learning, our starting point is learning is really important. Improving the way firms do activities is really critical aspect to making sure that we're getting the most profit out of the things like setting prices and various other marketing actions we take. So we're going to start with that as our going assumption, but also I want to motivate a broader motivation even beyond that already broad motivation we're going to specifically address here, which is that often we're using structural models in order to conduct counterfactual analyses that are assuming a lot of things about about firms in the nature of rationalization and perfect information, unlimited attention, so that they can get to maximizing profits in the way that our models assume. So you can think about like a static pricing model, and we want to apply this to do some counterfactual analysis related to a merger or various other things in the IO literature. And that imposes a lot of things in order to have such a model. So the problem is that although we make those assumptions, other evidence seems to contradict this. Things like survey research where firm managers say that they don't, they use cost plus pricing and various other kinds of heuristics rather than the kind of optimization routines that our models suggest. And other research that suggests they're not responding to things like local demand variation. And so this kind of behavioral side suggests concerns that maybe they're not learning in the way that you would want them to meet the kind of structural models. And more broadly, that general thing of, are they getting as much out of the, squeezing as much out of the fruit as you want? So our question is, do firms achieve adequate learning? And we're building off this Aghion et al. Paper framework where you can think about the agent achieves adequate learning if they acquire enough information that allows them to obtain the true maximum payoff. So what if they don't? Well, then in order to do the kind of structural modeling that we'd like to for the counterfactual analysis, you have to make a lot more assumptions about the priors, about the adjustment process by which they're reaching things. Whereas if they achieve adequate learning, you might think they're going to reach a state, an equilibrium, in which our models would be relevant. So what we're going to be asking here is how sophisticated or knowledgeable are major retail firms when it comes to setting prices? And our goal is thinking about a setting where they need to set new prices, how well they're going to do, and ultimately we're going to measure how close they get to the optimal. That's just going to evaluate that question of adequate learning. And then think about what did they know, when did they know it, and examine how the process unfolds, how firms differ, and then in this sense, try to descriptively characterize the learning process. So we're not going to be fully estimating learning. We're going to do something like you saw in the previous paper if you're here for the last part of the session. So this is what we're after, and the basic idea is we're going to focus on liquor, not to drink it, but to study how firms are pricing liquor in the Washington State post-deregulation market. So it was privatized in 2012. And we're going to look at how these retailers who were new to that selling of liquor in that market handled the pricing. We're asking whether they get to those optimal prices, how long it took if they did, and spoiler alert, they seem to get there, and what they had to learn, how they got there, so the features of that process. So our setting has some notable features that make all of this that's more a tighter analysis. One piece of this is that because they're new to products for this market, it makes it so that we can sort of narrow the set of things that they are learning about, the nature of the change in the environment. It creates this more controlled sense of the environment. The optimal policy in this setting, as we're going to set it up, is going to look relatively simple, yet high dimensional. So they have things to learn, yet we can think about this as a relatively simple learning task. And of course, we still have lots of confounds, like what other kinds of things are moving, what alternative explanations are there, and there's going to be features of this setting that are going to be really nice, including rich data on demand, actually relatively rich data on cost information that allow us to reduce the assumptions and be able to rule out or mitigate some of the major confounders that often are present in these kind of firm learning settings. So to give a preview, firms do make sizable initial mistakes, but eventually they seem to converge to textbook optimality, achieving that adequate learning. The mistakes that they make are mostly tied to distinct aspects of local demand. So Canadian whiskey is like really different here from elsewhere, and so some of the nature of the sub elements of the demand is actually important for them to understand, and so we can see the mistakes being tied to those. And they seem to engage in an adaptive process, which we describe as being quite consistent with learning about demand, and specifically from the realized quantities. We'll get into stock and flow of information so that both the stock previous information they brought to this context is important, as well as the flow of information. Different products have different coverage in terms of distribution, and so you might expect that the flow of information because of that would be better for higher volume products. And this process is heterogeneous across firms based on what we can see as their experience or capability. And it's more than just getting more information. There's also something that seems a little deeper about knowing the model better. So it's kind of nuanced aspects of demand that they seem to be learning. So to give a little context and data, by the way, this is different than Zoom. Is there a way for me to see everybody at the same time? Ah, there we go. Okay. So to give a little context about the setting, so I already mentioned they privatized in June of 2012. So the privatization there before the privatization was a state-run monopoly chain. So liquor could only be sold through that chain. They had a fixed markup that's going to play an important role when we're thinking about recovering costs. And the change was rather abrupt at the moment of the changeover to privatized sales. The chain exits, the state chain exits. Grocery chains are immediately carrying it in basically all of their existing stores that will carry it. So there wasn't like a rollout or something like that. So it's fairly immediate. And we also see at the moment of change a pretty significant increase in prices from the state chain prices to the grocery retailer prices. After that immediate large increase in sales in sale price, you then see a decline in price, and that's also connected to changes in price that I'll describe shortly. So this decline in price and changes in price over the next 2 years are going to relate to the period of the most learning. So you can see this sort of declining pattern in the figure here. Okay, so what's really novel about this setting from the firm learning perspective is two things. So they enter into this setting, it's newly privatized. It has high taxes relative to any other region in the country. So other states, you can see the range of taxes here, whereas Washington State is more in the 20.5 versus 0 to 10%, and much higher excise tax as well. So this pushes them into a different segment of the demand curve. The other thing is Washington consumers have different tastes, and the customer composition by product category is quite different as a result. So I'm going to talk a little bit more about that piece now. So the customer composition, you can think about it as across different sub-segments of liquor, and we're going to be focusing on whiskey. So the whiskey categories where we're going to be narrowing in. So I've given you two of the sub-segments for whiskey, bourbon rye and Canadian whiskey. And so you can see here that the light blue bar is the Canadian whiskey and the dark one is the bourbon. And what you see is that Washington, the pattern looks quite different across the income buckets of less than 85K and 85K and up. In particular, Canadian whiskey is higher for the high income and bourbon is lower for the high income compared to other states. So this reversal in preferences actually provides an important kind of nuanced aspect of demand that you'd have to learn in Washington if you didn't already have some context of those.
Can I ask you a question? So is there any explanations as to why Washington customers have so much different preferences than like anywhere else in the US? Or
yeah, so
Canadian whiskeys? It's kind of very interesting.
Yeah, so I mean, we have some hypotheses, but we don't have direct evidence about why that is. There's some thought that maybe they're close to the border with Canada, the sort of northwest part of it. They're further away from some of the bourbon producers compared to most of the rest of the other country. But we don't know for sure why this difference exists.
And this diagram is drawn after controlling for the prices and etc., right? So
I'm not sure what you mean by after. So this is just descriptively.
Right, I understand, right? But still, if, for example, in Washington, sorry if I interrupted, but for example, if in Washington, Canadian whiskeys used to be priced like much lower than everything else, then this might happen, right?
No, I don't think that's the issue, if that's what you're asking.
Yeah, I see.
No, I don't think this is over the period where, that's a good question. I don't recall the exact period, but this is later, so this would include, where it's priced differently, but that's a good, so we can investigate if this is consistent with the earlier period too. It's a good question. It's a good question. Yep. I don't think it is, but different.
A great thing to check. Yeah, I think so.
Yep. No, it's a good point. Thank you. Okay, so
just a quick. Have you checked the currency fluctuation with Canadian and U.S. dollars?
Yes, so we have looked at the currency fluctuations. They can be related to the underlying costs that we can observe in the setting. We can observe those because of the regulated period and other regulated states. So there clearly seem to be varying costs related to those exchange rates. Okay, so our story here is that the retailer's primary challenge was learning the right prices. In other words, they had to learn demand. And that Ching's learned about that demand from their sales, so the experience through the sales, and they build on any prior experience they had. So one of the firms in particular is going to have some prior experience in other markets, where others will have been more local and didn't have this privatized, didn't cover any privatized markets, and that they gradually converged to essentially profit maximizing prices, achieving that adequate learning. There were large initial mistakes, and the type of mistakes that they had seemed consistent with category level customer composition differences that I just showed you. Okay. So there are a few alternative stories that appear not to be first order. We've done some meaningful effort to rule out, and the context allows some statement about. First, consumers aren't learning their own tastes. Okay, so liquor was offered in the state long before retailers were offering it. The set of assortments were relatively consistent in broad terms across the pre-post period. So it's not a new category. What we estimate is demand is quite stable in terms of the way consumers are buying. So consumers seem to be stable in their tastes. Okay? Firms aren't seeming to be learning about the right product assortment as the main story. So we're going to focus on the stable core assortments, which captures 90% of the revenue. So that's what we're going to be analyzing. So there's some assortment changes, but they're on the small side, and it's a small part of the total volume of revenues. So we're going to be focusing in on those the core assortments. And the firm learning is not so much about the market structure and conduct. Okay, so it's not focused around changes in market structure and conduct. We examine to what extent customers are cross-shopping. We find little evidence for that. There's little changes in purchases if you think about changes in assortment in other chain stores in the same market, or promotions of other chain stores in the same market. So it's really these liquor purchases are kind of customers come to the grocery store. They have a monopolist position in that sense, and then they're pricing these liquor products with that intent. And we also see stable retail and wholesale market structures over the period that we're studying.
So there was no entry of new liquor stores after the lift of the regulation?
Yes, there were later in the period. If you look at the shares of sales over the period we're focused on when this learning is happening, it's quite stable.
I see.
Now, the roadmap for what I'm going to talk about, so a lot of the stuff we're going to be doing, I'm going to start with some descriptive evidence, more directly looking at the data using kind of reduced form or descriptive analyses. And then I'll move to structural analysis, where we're going to evaluate the actual sort of true demand primitives in some sense, with the goal of being able to measure whether or not they're achieving adequate learning. I'll give some test of that, and then using the assumption that they've achieved adequate learning based on the test we have, we'll evaluate the breadth, the persistence, and the nature of the pricing mistakes they make. What we find there is that retailers do learn about demand, as I mentioned, converging to full optimality. The mistakes are consequential in terms of profit. It's about 9% of the profits they've been able to achieve are lost because they don't yet have the information. So they recover that much from the learning. So it's pretty substantial in terms of profits. And those initial mistakes are consistent with that composition element. The learning does happen pretty quickly. Most of it's in the first 2 years. Information is playing an important role here, and there is a knowledge transfer that's fairly nuanced. So that's the roadmap. I'll be laying out these results as I'm going through the analysis here. Okay, so I'm not going to spend much time on the related literature given the time of the talk, but we're connecting to the learning literature. A lot of this is empirical examples in actual contexts, but there's obvious connections to the paper, the kind of stuff that the paper was doing in the last session. So thinking about more from the firm side, and then we're connected to some work that looks at convergence of equilibrium. It's a little different than the kind of learning we're talking about here, but learning the equilibrium. Connected to bounded rationality work, things about managerial skills that underlying these learning routines. Underlying this learning is probably routines that are based on that managerial skill side. And then we're also studying the retail liquor market, so we connect to that literature. So the data in this setting is about it's mostly aggregate store level data we're using from the Nielsen Retail Measurement Service. Focused on the whiskey category I mentioned, so that's whiskey and the bourbon rye category, so both American whiskey and Canadian whiskey, and then the Scotch Irish. So we are going to study 4 grocery chains and 2 drugstores for the demand estimation. When we get to the pricing analysis of the supply side stuff, we're going to narrow in on just 3 of the grocery chains. That's one of the grocery chains experiences some structural things where they, some chains closed unrelated to, or some stores closed unrelated to liquor, and so we don't want to get that sort of in the mix of the discussion. So we're also going to add some auxiliary data. Some is using RMS data of other retailers in other privatized states. So that's going to be for comparisons. I'll be showing you shortly. And the Nielsen home scan data is going to be used for some detailed consumer behavior stuff and constructing our micro moments that we use for the estimation. And we're also going to use some public information about wholesale prices that can be recovered related to wholesale prices based on this privatized, so the before privatization in Washington and regulated state prices in Oregon. And that allows us to recover the costs that the retailers would face. One fact about this that we're going to take as given throughout is that state level uniform pricing is largely what's happening here. So this is consistent with the recent behavioral literature that shows that in setting prices, they do them without accounting for some of the local variation. It appears in this setting that the prices are set basically at the state level. There's small variation, but very, very little compared to between chains and between products. So descriptive analysis, the first thing we're going to examine is the nature of response to quantity shocks. So if retailers are learning from realized demand, then they're going to be responding to quantity shocks and adjusting the prices in response. That response here we're capturing in this regression where the row on the price, the previous price, is capturing that persistence in the price, and what we're really focused on is the beta tau there on the previous quantity. We added a number of controls. The beta tau is has the subscript taus that we're going to use half-year intervals, so pooling over half-year intervals. How much did they respond? If we would expect learning, if you think learning is happening, then you'd expect the pattern to decrease over time. So starting off relatively positive, significant changes in price response to these quantity changes, and then as they learn more what is going on, the price changes would decrease in response to the quantities. So the results here are shown in the two figures. You can see for Washington State, it exactly has the pattern you might expect, that you start with this higher level, and then after about 2 years, it looks like it drops down quite a bit and settles at a much lower level. Whereas other states, you see a pattern where it's quite flat throughout. So this is suggesting this contrast, the sharp contrast between the two, suggests that firms are becoming more informed, and that the randomness in the sales shock seems to affect the price less and less as they incorporate more information to the prices they are using. So this is first evidence suggestive of responding to quantity information. Second piece of descriptive evidence is about capturing the market fundamentals in those prices. So if firms are learning, then they're going to be incorporating information about those market fundamentals right into the prices, which is going to mean that the market fundamentals that in the regression I'm going to show you will be in the residual, will create an endogeneity between price and those residuals. So this is the kind of normal endogeneity we're trying to get rid of when we run our demand estimation. Here we're going to run it without accounting for this concern. And what we would expect is as they learn more and are incorporating that market fundamentals into the price better and better, that there's going to be an increase in bias in that coefficient on the price. So this regression we're going to run is going to use the cross product variation and capture that sort of pooling over 6-month periods, just like the last one on the alpha tau. And if they are learning about demand, we would expect that alpha tau to increase over time, reflective of the bias due to endogeneity. That's exactly what we see for Washington. You see this pattern of increasing coefficient on the price. That would be the increasing bias on the price over time until it sort of stabilizes after about 2 years. In contrast to other states, like in the previous graph, is basically flat and not seeing this kind of pattern at all. Other states are where firms presumably have already learned how to price based on the market fundamentals. So these two pieces of evidence suggest that firms are incorporating information, that information is meaning that they building in the market fundamentals into their prices, and as well they're learning about demand, and that in other states they're not. So that learning seems to happen relatively early, for the most part in the first couple of years. By the end, it seems like they're quite stable. So that's going to be something we're going to be setting up as a starting assumption for our structural analysis. So in the structural analysis, our goal here is to estimate demand so that we can then use those demand estimates in order to say more about the nature of behavior. So first, we're going to evaluate whether adequate learning is achieved, and then we're going to study the nature of the pricing mistakes in the learning process. So in terms of evaluating the adequate learning, we're going to recover consumer preferences through the demand model. Then we'll impose a supply model only at the end of the period. And by end, I mean the last 6 months. Use that to recover the costs, which is those wholesale prices. And then we'll sort of move that back in time to the pre-privatization, and match that up with the wholesale prices and the model implied ones. So that way, so that gap between those tells us, if there's a big gap, it would tell us, hey, it looks like they actually don't have optimal prices at the end. If there's a small gap, we're going to imply that that means there's adequate learning. And then we're going to use the implied cost and demand system to measure the nature of pricing mistakes. Okay, so the demand model is relatively standard looking overall. You've got category level intercepts, so that gamma K I, so those are category level intercepts for different categories of the whiskey within liquor. Because we're retailer market level, RM, and then this is monthly, so we've aggregated to monthly. Assuming they arrive at the store to buy groceries and they buy liquor while they're there. We have heterogeneity both on the category instance and the price effect. We also have some other controls related to display and promotion, and then a large number of fixed effects for product retailer markets and retailer time. In this analysis, we're going to be focusing just on the product size that is the sort of core size, the 750 milliliter bottle. And that's also from talking with managers in this industry. That's the one they focus on when they're setting prices. Okay, so in terms of consumer heterogeneity, we allow for log income to have an effect. So we allow those category intercepts for to be driven by the log income in terms of heterogeneity. And for price coefficient, we add to the log income effect, we also add a random normal so that there's some difference between the two. They don't have to have the same pattern. Okay, so the estimation here proceeds with BLP using micro moments. The usual BLP type aggregate data moments that we're using are the average price of J and other retailers in other markets, following the literature here. And then for the random coefficients, the number of products in the retailer market is going to be helping identify. But we're going to add some micro moments by income bin that's really going to help pin down the heterogeneity. First part of that is probability of purchasing liquor by income bin. And then the other ones are conditional on purchase, what is the share of the category K, and the average price paid for that category. So this is the moments we're going to use using GMM estimation, fairly standard once you have these moments. So what we find in terms of parameters and elasticities, everything kind of makes sense, what you'd expect in terms of signs and magnitudes, things like that. The mean elasticity for the price coefficient, the price elasticity is negative 3.94. That's really quite consistent with prior liquor studies. Makes sense. We're using similar style of model to many of those studies. We also estimate demand and find it stable. So I mentioned this earlier, where we said, I said the consumers don't seem to be learning. The demand response to all the different elements seems to be stable, and the fit is good throughout as well, suggesting there's not something changing that means there's some instability in the function. So I'm going to take this as given for what we'll talk about next. So the next thing is the recovering the wholesale prices. Some questions here. Okay, Yufeng is responding. So in order to decompose the implied wholesale prices, we're going to use this function here, where we have a product retailer effect that we're going to recover from the full information assumption at the last 6 months of the data. Okay, so we're going to assume the last 6 months of data, they're optimal. We can then recover the C bar JR. That C bar JR, then along with one other piece, will be how we move prices backward in time. So our cost function looks like you see here in this equation. The second part is we're going to use Oregon costs. It's right next to Washington, and presumably faces similar kinds of impact of some of the underlying costs. We do find that the mild cost trends that are there are consistent with inflation and as was mentioned earlier, TI exchange rate fluctuations.
Sorry for interruption. You have 10 minutes.
Yeah. Question? Question?
No, you have 10 minutes.
Oh, okay. Yeah. So, so the combination of these two is how we're going to be treating costs. So we're covering the cost of the last 6 months. We're going to walk it back all the way to the 2012 time period where the privatization happens. And from that, we're then going to evaluate whether or not they've converged to so full optimality. So if we get the wrong costs, we wouldn't expect by the time we roll it back these to correspond very well at all. Instead, we find the correspondence between the state-owned chain's costs and the ones we recover and then move back in time to match up quite well. So correlation here is 0.99. You can see the graph there. The median observed at 1236, the implied is 1211. So it's quite similar. We're going to take this to mean firms achieved adequate learning, so they converge the full information by the end of the sample. Okay, so all the firms, so that's sort of starting points. All the firms are getting there eventually. And so now we're going to think about how far off were they at the beginning and what did that process look like. So the beginning mistakes, we're going to measure those with a difference between the actual absorbed price and the optimal price, assuming those costs, and make that relative to the optimal price. What we find is the initial prices are 9.3% above the optimal in the median, and there's significant dispersion. You can see the density plot here of the pricing gaps. So this is leading to substantial suboptimality, 9% below the optimal in those initial prices. So that's the size of the information gap that the firm is experiencing. Now, 2 years later, they've already learned a lot. So you can see here the pricing gaps have shrunk a lot. So this dotted blue line is the pricing gaps at 2 years later. Okay. At this point, the median price gap is actually 0. It's sitting right on top of 0. The dispersion much, much smaller. And that leads to a profit improvement of, now they're now down to 3%. So more than 2/3 of the profit is now actually recovered and is recovered by the firm. So there's still suboptimality, but a substantial amount has been eliminated, and they're going to continue to sort of push this out. So now what I'm going to think about next is the information stock. So different firms that we're studying have different experience. So firm 32 in particular, the one on the right in this figure, has more experience than the other two. That they have some stores in states that are already privatized. They were selling liquor in other states already. The other two are not selling liquor in other states. And so you can see here, there's a substantial difference in their initial position in terms of their price gaps. And that translates into substantial differences in the profits as well. So the initial profits for the two inexperienced players were between 12 and 15% off, whereas it was only 6% off for the firm that had experience. So those price gaps, you can also see in this figure, they have different processes of reducing those. For the experienced player, that firm almost within the short period of the first year already has closed the gaps to match closely with the 0, whereas the inexperienced players are still sort of bringing the price gap down over time. But even within those two inexperienced players, there's some differences across them. So they still had some scope for learning, even among the experienced player. You can see that happening fairly quickly there. So that's about the stock. So experience does matter. The second part is about the information flow. So if they're learning from signals of the sales, it will matter if they're being sold in more outlets than fewer outlets. And what we see is that the high volume products, so we do a median split on the number of products, and the high volume products here have a lot more, so a lot more quickly reducing the width of the gaps and reaching the zero much more faster than the low volume products. So we conclude that the information, both experience and observed sales, play an important role in learning. All this is consistent with the idea of learning. And keep in mind, we have not estimated a learning model here. We're just describing this process from backing out optimal prices and comparing them to what they did. And the last piece of this is about the nature of the initial mistakes. And the question, the way I'm going to frame this here is that the question is, can the biased beliefs about the customer composition explain the initial mistakes? And remember, those customer composition graph that we talked about at the beginning is going to relate to the parameters, the gamma ki. So do those gamma ki parameters, are they able to capture biases in their beliefs? Now, first take of this is depicted here in this graph, where you can see Canadian, Irish, and bourbon, and how different the distribution of price gaps are for these three. Okay, and it suggests there are differences in how off their prices are at the beginning. So the question is, does that can biased beliefs explain what's happening with those prices? So to formalize this idea, we calibrate a simple model where we're going to assume that the optimal pricing policy is set, assuming some belief, and then we're estimating the size of the bias about the gamma k. So how much off from the true gamma k are they in order to explain the variation in the actual prices that they give compared to the full information optimal prices. So when we estimate this model, we find that we can explain 50 to 60% of the initial mistakes. So that's a pretty large portion of mistakes with just these gamma k's. Okay, so that's the only we only insert those as flexibility. The types of mistakes are similar in nature across retailers, but different in magnitude. I'll talk just a little bit more about that in just a second. And in contrast, like if you think, well, maybe they're just learning about the price sensitivity, but it's not really about these gamma k's. It's not about this nuanced piece of gamma k. It's really that they just didn't know how sensitive people were to price in this setting. Well, if we try to allow just the price sensitivity, we can only explain 10 to 25%. Now, that doesn't mean that price sensitivity isn't also part of the story, but the bulk of the story seems to be centered around the gamma k's. So this is suggestive that firms are learning something pretty nuanced about consumers with this income distribution and the nature of customer composition, that customer composition in terms of what they like and they're going to purchase. So dig just a little deeper on this, recognizing getting low on time. The experience of the retailers is different. So I have here in this figure, we have 3 different columns, one for retailer 32. That's the experience guy, and you can see the biases are in those first 3 columns, and you can see they're lower for retailer 32 than the other 2 retailers. The direction of the bias, though, for all 3 retailers is consistent with the difference between other states where they might model their initial prices off of, and Washington State. Now, what's really important is the retailer that has the experience. You might think, oh, well, they have experience, so they're going to follow what they did in other states more. Well, actually, they follow the price levels or the relative price levels between products in other states in some sense less. They seem to be incorporating an understanding of the model here, so they know the model better. It's not just simply forecasting. They're calibrated about the model in terms of the consumer underlying consumer tastes might be shifted here versus other locations. This is suggesting a pretty nuanced understanding of the demand system. that is derived from that experience. So to conclude, in a setting that we think is really well suited for trying to isolate this learning aspect, we find evidence that firms achieve adequate learning. In particular, we find a range of descriptive evidence, as well as evidence from the structural estimates that the stock of experience and the flow of information are both affecting the learning process, so that experienced firm versus inexperienced firm, and then how much sales volume products are getting in terms of different across different products. And we characterize that learning as about this nuanced aspects of consumer demand, suggesting there's probably some kind of routines underneath this that are able to capture important features of customer composition and the way that affects demand. Okay. Well, thank you very much. I'll let's turn it over to Nitin.
Thanks a lot. Thanks a lot, Mitch. It was very nice. Thank you. So now I have to see, how do I upload my slides now? Okay. Let's see, upload from my computer, learning to set prices. Okay, so it's uploading it right now. Looks like you upload. Okay, that's fine. Okay. Okay, can everyone see this?
Yes.
Okay. Oh, that's wonderful. All right. So, well, thanks a lot. Thanks a lot for the organizers, especially Nanda Kumar, my dear friend, for giving me a chance to be a discussant for this paper. So it's a pleasure to it's a pleasure to be here. So the paper is Learning to Set Prices. It's by Huang and Mitch and Paul Ellickson. So let me just start with saying that, that in empirical IO especially, the status quo is assuming rational expectations, which is that rational equilibrium models of competition, essentially we assume that, and they incorporate two assumptions. First is that firms form beliefs about the uncertain demand, costs, and the competitive behavior, and they maximize their profits based on those beliefs. So that's taken to be given. And the second is that the beliefs coincide with the actual distribution of demand, costs, and competitive behavior. So it's the second one that is a critical one. That's what we call the rational expectations. And there's a reason for making that assumption. Even though it might be restrictive, there's a reason for making that, because it has identification power. And it also helps with counterfactual analyses, which is that the model predicts how beliefs will change endogenously as you change the policy. So there's a reason for that. But of course, that that if the rational expectations assumption is not satisfied, then it can give you completely incorrect results in your counterfactuals. So there have been recent structural empirical papers of competition that have relaxed the assumption. The foremost one is Avi's paper with Moshow, and Victor's paper, Aguilera and Magnuson, which is in their Aristot paper, in which they relax the rational beliefs about the competitive behavior. It's the beliefs about how their competitors would behave. And then Doraz, Lesky, Lewis, and Pecos, and this paper, they relax the assumption about the competitive behavior / demand. And the firms are allowed to learn either the competitive behavior or the demand over time. And the idea in the last two papers is that the biased beliefs, that firms can have biased beliefs about the demand or about the competitor's behavior, or both. But these beliefs will evolve endogenously over time, and over time these will become the equilibrium beliefs. And that's what we saw, what Mitch talked about, that in the last 6 months they became the equilibrium beliefs. So the incomplete information in environment converges to the complete information environment in the last 6 months, what we saw in Mitch's presentation. Now, what's the objective of Mitch's paper? The context is that the privatization of retail sales in alcohol in Washington state, there was privatization there. So from a state-run monopoly to a collection of independent retailers. So it was a straight-run monopoly before. Now you have independent retailers. They're learning how to set prices because they've never set prices in that state. They may have set prices in other states, but the demand condition in the state is quite different. Now, even though the demand is stable, but they're learning about the demand. That's the idea. So the goal is to empirically examine the process by which the firms learn to set prices, and they have specific objectives. there are 4 specific objectives. First is that, is there learning going on about the demand and for how long? Then what are the moderators about this learning? So what are the moderators of firm's characteristics or the product characteristics that impact the rate of this learning? What's the economic impact of this learning? That how much money are they losing if as compared to the case where they had perfect information? And which features of the demand are retailers learning about? Is it the distribution of price sensitivities or the preferences of the different product categories? Given that, they first start with reduced form analyses, and I think this is a really nice, neat part of the paper I found. They run 2 reduced form analyses. The first one is just to check the correlation between the present price and the last period's demand shock. Now, if the firms are learning from the last period's demand shock and setting their prices based on that learning, then there should be a correlation between the last period's demand and today's price. And not only that, this correlation should decrease over time because you would learn more initially, and after that, you just reach into a steady state then. And this is exactly what they see, that firms learn from the past demand shocks, and the learning basically ceases after 3 to 4 years because this correlation just becomes pretty much zero in the end. Then the next reduced form analysis, this is, I think, a really neat one, which is that they check over time whether prices reflect the demand fundamentals or not. So what you mean by demand fundamentals, what Mitch means by that is that higher demand products charging higher prices and lower demand products charging lower prices. That firms will come to know what the intercept in the demand is, in the demand function is, and based on that, they will just charge different prices. Now, the way they do it is actually fairly neat. So what they do is that they run multiple cross-sectional regressions over time of demand of products on their own prices. So they have the demand on the left-hand side and they have the prices on the right-hand side, and they run multiple cross-sectional regressions. But the key part here is that they do not include the product fixed effects. That's the key part. And then they want to check that the coefficient of price in these regressions, how does that change over time? Now, keep in mind that if there are no fixed effects, and if high demand products charge higher price and low demand products charge lower price, then of course we have the endogeneity bias because we're not controlling for that bias because of the fixed effects. The result would be that there'll be an upward bias in the price coefficient. So it's straightforward to see that. But if there are no fixed effects, and if the high demand products charge random prices, for example, if the firm does not know that my product is a high demand product, and so they're just starting with a clean slate completely, then you would not expect high demand firms to charge a higher price and the low demand firms to charge a lower price. So what that would mean is that in the case when the firms do not know, then the upward bias and the price coefficient will be a lot smaller. So that's the test here. If you look at these 2 points here, so let me just go back. I don't know why it's moved here. That because of learning, what we'll see is that the coefficient of price goes up in magnitude. It starts with being more negative, and then it becomes less negative over time. Because as firms are learning, it becomes less negative over time and it flattens out. And that's exactly what they see here. Now, of course, the one caveat that I would say here is that this is a demonstration of the fact that firms are that prices are reflecting the demand fundamentals. It's not necessarily an evidence of learning because it's based on the assumption that the firm's priors are relatively flat, that they are quite clueless in the beginning. So it depends on what the prior beliefs are. So for example, I can just switch the prior beliefs. If the high quality firms or the high demand firms think that their product is much better, if their intrinsic priors are much higher than what they truly are, and the low demand firms think that their priors are lot lower than what they truly are, then still it would converge, but not in this particular fashion. So that's just a little caveat that's there, but it makes a point that it reflects the true demand fundamentals. Then they have the structural model of demand. It's a standard random coefficients BLP with micro moments in it. Then they have the supply side model. The assumption that they make is that every retailer is a monopoly. Every retailer is a monopoly chain, and they provide very fairly reasonable justifications for that. So it's believable that it makes sense. So the first thing that they do is that they estimate the supply side from the last 6 months of the data, because they've established that there's no learning going on. It's become full information then. So last 6 months of the data, they've calculated what the marginal costs are, or not the marginal cost, the costs or the wholesale prices. Now, they've calculated the wholesale prices for the last 6 months. Now, how do we calculate the wholesale prices for the 3.5 years when the learning was going on? Now, the assumption that they make here is that, yeah, sure, the cost would vary over time, but the percentage change in the cost over time in the Washington state and in the neighboring state, which is the Oregon state, that would be the same. That's the assumption that they're making. So if you make that assumption, and if you know what your costs at the end are, you can just make that assumption, and you can see in the Oregon state, you know how the costs are changing, because Oregon state is not just that is just close by. It has a state-run monopoly. If it has a state-run monopoly, you can back out what the costs are. So you can back out what the costs are. You can then back out how the costs are changing over time. You assume the same trend for Washington market, and you can back out what the costs there are for the entire 3.5 years. So that's the rationale that they're using here. Fair enough. And then given the cost, then it just becomes, you can just do the counterfactuals right away. The economic impact of learning and the moderators of learning. So for example, for the economic impact of learning, for the 3.5 years when you're learning, you just try to assume that there's full information and calculate the optimal prices, and then compare the prices with the data and the profits with the data, and just then see that, okay, what is the economic cost that is there? And the moderators of learning, whether the firm has experience in the market or not, and whether the product is a high selling product or a low selling product, and so on. That Mitch has already talked about that. So here are my comments. I'm going to take 5 minutes to make these comments. Overall, a solid paper. It tackles an interesting and a difficult problem. Difficult, I have to emphasize that. A bounded rationality in the empirical IO is not an easy thing at all. It's just not an easy thing. It's one thing I have to say is that it's exceptionally well written, extremely well written. It was actually a pleasure to read. The reduced form evidence is compelling. That's a really strong part of this paper. The counterfactual analyses are interesting. I would say that they're fairly interesting counterfactual analyses. Now I have 4, constructive criticisms to make. And so let me just start with the constructive criticisms. The first is the comparison with Doraz-Selesky et al., which is the AAR paper. Now, in the paper, the authors have mentioned this. This is what the authors have just written one sentence about comparing their paper with Doraz-Selesky, which is that while the emphasis in Doraz-Selesky et al. Is on strategic learning about competitive behavior, our emphasis is on learning about the underlying demand. Well, it's not really. Doraz-Selesky, they actually they emphasize both types of learning. It's learning about the competitive behavior, which they call fictitious play. And they also talk about learning about the underlying demand, which they model as that adaptive learning. And they've emphasized both of them. Now, while it's true that, that all papers are built on prior literature, and there's nothing wrong in that, but I believe that it's important for the authors to discuss the similarities and the differences and let the reader make their own inferences. So for example, let's look at the similarities. Both assume rational expectation. First of all, the big difference is that the context is different. Because in Doraz-Selesky et al., the context is about the frequency response market in the UK electricity system, and their context is in the alcohol market is in Washington state. But both assume rational expectations equilibrium in the last part of the data. It's the idea is similar. They use that to recover the costs, and given the costs, then they run the counterfactuals on the learning part of the data. They both study how the learning evolves over time. They both study the economic costs of learning, and both study the main sources of demand uncertainty. Now, the main source, whether it's the price coefficient or the preferences, etc., both of them study that. But the key differences are as follows. Reduced form analyses, that's a very strong, big strength of this paper, because Doraz-Selesky, they really don't have much reduced form analyses. They have some, some descriptive analyses that they've done, but it's not as clean as what Mitch has done in his paper. Counterfactuals, Durza-Zaleski did not study moderators of learning. So that's something what the authors are studying here. They did not really study the sources of demand uncertainty as much detail, as much nuanced detail as what Mitch is studying. Mitch and his co-authors are studying, whether it's price sensitivity or the preferences at different income levels and the Canadian whiskey and the non-Canadian whiskeys and all of that. It's much richer here as compared to what Durza-Zaleski et al. Have done. But it's important to just make it clear. And there are some important differences. And it's, yeah, someone has their mic on. That's fine. Okay, my next comment here is that the authors have assumed an AR1 process for the demand shocks or the unobserved brand characteristics, but they haven't really explained why that is needed. Now, I understand that it's done in Durza-Zaleski et al. They do that, but the reason why they do that is because they don't have any unobserved heterogeneity in the demand model. And they just use this AR1 process so that they can difference out the demand, and they can difference out the demand equations that are there, and then they can use nonlinear least squares. I really didn't see the need for the AR1 process, or if it's there, then I think the authors should just explain it. Now, this is a critical one. Now, it could be that I haven't understood this part here. Let's look at the instrument for the prices in the demand model, in the BLP demand model. They've used essentially the Hossain instruments. The Hossain instruments are that I'm going to use prices from the other markets or the other states that are there. Those are the Hossain instruments, and those will be the instruments for my prices for the product in this market. That's what they've used here. Now, it's really important to understand that the Hossain instruments basically work when you have product-specific fixed effects. If you in the paper, they don't have product specific fixed effects. They have the product type fixed effects. They have for whiskey, they just have 3 or 4 fixed effects, not the product specific fixed effects, because they have 720 products. They don't have the product specific fixed effects. They have the product type fixed effects. Now, why is that so? Because keep in mind that the random error in the demand model, in the BLP demand model, it captures the unobserved brand characteristics, which are the time invariant brand characteristics and other time varying demand shocks. Now, once you control for the time invariant product characteristics in the regression through the product specific fixed effects, then the prices in other states will not be correlated with the time varying demand shocks, because that's all that's left in the focal state, as long as we're assuming that there's no national level campaign. So that's the idea behind what Nivo does, etc. Now, the authors have control for the product type fixed effects, which is the whiskey type, whether it's Scotch or not, but not within Scotch. Is it black label? Is it blue label? It is red label? What kind of a label is that? So it's either the authors, I would suggest that, just justify this assumption here or try to work your way around that. And finally, recovering costs from recovering the wholesale prices for the learning period. The authors are assuming that once they've recovered the prices for the end period, how do you recover the costs, the wholesale prices for the middle period where they're learning? The authors are assuming that the percentage decrease in the change in the costs in the Washington is exactly the same as that in the Oregon state, which is fine. You can make that assumption because these are neighboring states. It makes a lot of sense. But is it possible? Now, this is my question only, maybe it's just out of complete naivety that I'm asking this question. Is it possible that the wholesalers in Washington during the learning period are also responding to the changes in the retail markups over time? I know that the retailers, their markups are changing because they are experimenting and they're learning. Is it that my markups are also changing because of that? Is it my wholesale prices also changing because of that? Now, if that is true, then this assumption will not hold. But if it's the case that the wholesale prices are just going to be the same over the period, they're going to follow the same pattern, then it's fine. So that's all. So overall, it's actually a very nice paper, solid paper, tackles a very difficult problem. And keep in mind that, Mitch, that the constructive criticism that I'm giving here, if I were the AE or I were the reviewer of the paper, I would just say this, acknowledge it and move ahead, if what I'm saying is correct, because you can't do all the things in one paper. It's just not possible. So the paper has some very good things, acknowledge the things that are not there, and If I were the AE or the other reviewer, that's what I would say. So I'm just pointing out the points that are there because as a discussant, I have to. That's the reason why I'm pointing them out. But it's actually, but you know, irrespective of that, I would say it's a very nice paper. Yes, it has some issues, but it's an extremely nice paper. It's very, I would say it's one of the most well-written papers that I've read recently in the last 6 months or 1 year. And very compelling reduced form evidence, which the other literature does not have, and some very interesting counterfactual analyses. So that's the end of my presentation. Thank you.
Thank you.
And Mitch, if you want to discuss that offline, I'll be happy to do that. Any questions, any points that you have. Okay, Mitch? Yeah, take care, guys. Take care. Yeah. And sorry, Nanda, for taking time.
Not at all. That was a great discussion, Nitin. Thanks for handing it off. And
yeah, thanks.
Thank you to the committee for including this paper, and thank you all for coming to this talk. And thanks a lot in advance to Shaolin for the discussion and comments. If I may have one suggestion or request, I'm not able to see the chat while I'm presenting. If I try to, it boots me out. I had this happen earlier in the panel. So I prefer that you just jump in and ask questions as we go along, and I will make sure that I will make time for that. The paper I'm going to present today looks at gendered academic achievement gaps in business schools and is joint work with Aradhna Krishna, who's also at the University of Michigan. Now, we all heard about the gender gap in earnings and career progression, and as a background, across management jobs in the US, women earn about 77 cents for every dollar earned by men. Much of this discrepancy has been shown to result from the fact that the ratio of women is lower in these high-paying careers. Low levels of participation is undesirable for at least two factors. First, it handicaps economic growth. This is one of my favorite recent papers that provides evidence for that. It is also said to be linked to undesirable culture and outcomes for women who are in those industries or companies. This is indeed a problem that companies have been paying attention to and trying to tackle. And one of the problems that a recruiter suggests seems to be the pipeline. If you ask recruiters, they oftentimes lament that there's not a large pool of well-trained women to choose from because women don't take the academic paths that lead to these professions. Now, business schools train this pool of talent, and since we do, we wanted to look at a close look at this conjecture. And consistent with some of this lamenting, when Bertrand, Golden, and Katz looked into the earnings and promotions of MBA graduates, we're going to be looking at undergrads, but MBA graduates from Chicago Booth, they found that gender disparities in careers and earnings stemmed partially from gender disparities in GPA and how many finance courses students took. So this paper suggests disparities may also begin at school. Now, most of the prior research on gender differences in academic achievement focus on STEM. This research usually points to the underrepresentation of female students as the reason for women not to perform well or not to self-select into STEM fields. There's certainly insights to be gained from this literature, but at the same time, business schools are quite different. So they boast about near equal gender representation. In fact, in the US, it's about 43 to 47% of the student body in undergraduate business education are women. So the issue definitely requires a closer look in this context. Business schools also have quant and non-quant courses and skills, and they possibly attract quite a different type of a student body, or perhaps have a different culture. These differences have immediate downstream consequences for the corporate world that motivated this question to begin with. So in this paper, our first goal is to document academic performance disparities across men and women. This is referred to as GPD, gendered performance difference, in the literature, and I'm going to be calling it that for the rest of the presentation. we document large GPDs. So for comparison with the previous literature that found about 10 to 15% of a standard deviation difference in grades in STEM, we find that overall women's grades are lower in quant courses, about 11% of a standard deviation, and men's grades are lower in non-quant courses, poet courses, and that's even larger, about 23% of a standard deviation. Note here that, just as a preview, we are comparing students who ex ante are going to look very similar in terms of their aptitudes and demographics. So these are large differences. The differences in STEM have garnered a lot of attention, and just these, descriptive statistics will tell you alone that we should be taking a closer look at the business education. Now, why is this happening, and can we do something about it? So that's our second goal, is to provide evidence for the plausible mechanism behind this finding. The previous literature discussed about 3 mechanisms, and mostly based on extant theories from psychology with some correlationary evidence. Those are perhaps students' differences, they have differences in innate preference or ability. If that's the case, context shouldn't matter. The second one is perhaps students have different expectations of success or ability or belonging. So in other words, beliefs that may shape their interests, their motivation, and ultimately their performance. And importantly, of course, if there are such differences in beliefs, they could be self-fulfilling, even if they're inaccurate. For example, if women believe that they can't do well in quant or finance, such beliefs may actually impact their performance. So to the extent that these beliefs come from certain stereotypes that they might have heard of even before they joined college, psychology literature shows that providing salient counterexamples to stereotypes, such as an instructor, a role model, graduate, can really be effective. And the third potential mechanism is on the faculty side and includes instructor grading bias or differential behaviors towards students. These may be implicit or explicit and perhaps fed by some of the same societal forces. If differences stem from the instructor bias rather than the student bias, we might expect them to extend to grading, and to the extent they do, we might expect that the more subjective the grades are, the bigger this bias. So in this paper, one of our contributions is to improve upon a lot of correlational evidence to provide some causal evidence about the mechanism. First, through a survey, we show that students report gender stereotypical expectations of performance. And then we show a causal relationship between the instructor gender and GPD. In particular, we find that GPD is reduced if instructors are female in quant classes. Our ability to provide a causal relationship is based on 2 factors. One, we have an exogenous student-instructor assignment mechanism in the school we study, and courses are mandatory. So this rules out student selection biases that have been a problem for most of the research, except for the 2 papers cited there. In addition, we account for the fact that in marketing classes, yes, students are randomly distributed, but marketing classes are probably more likely to be taught by female faculty compared to finance classes. The gender of the instructor is not randomly distributed. And so we're going to be controlling for student gender performance course fixed effects to take care of this potential aggregation bias, which other work has not been able to do so far. Finally, we're going to provide some evidence, if I have time to discuss today, that instructor bias is not a likely factor in explaining the majority of our results. So let me tell you a little bit about the data that allows us to get at these questions. We're going to be using a very rich administrative data and a 15-year-long period spanning about 6,500 undergraduates at a top public university, at a top business school. We see the students' grades in all the classes they take, but in addition, we're able to merge it with their application materials, which gives us kind of some of the aptitude measures that you may be wondering about. How well did they do in high school? How much calculus did they get in high school? What AP tests did they take? What were their grades? Same with the SAT, ACT scores, broken down by science, math, English, whether English is a primary language at home, and then family background characteristics such as their income, education of the parents, as well as the student ethnicity. We link the courses and the grades they take to instructor demographics, which is also from this administrative data. As you can imagine, female and male students may differ in a lot of dimensions, you know, in addition to their gender. So we find that women tend to be more underrepresented in other ways. For example, they're more likely to be non-white, they're more likely to be first generation. We also find that men coming into this program have stronger math scores, but lower high school GPA, whereas women coming in have higher high school GPAs and stronger English scores. So what we'd like to do is compare two identical students except for their gender. So we're going to need to control for those background characteristics. Same thing with instructors. We have their position at the university, their experience, how long they've been teaching in the core program, as well as ethnicity. Our focus is going to be on the core curriculum in the undergraduate education, and we pick the core curriculum for a couple of reasons. First of all, their introductory coursework, and we want to focus on the introductory coursework because it matters for future focus. So if you're very successful early on in quant classes, chances are that you're going to continue in that path. Interestingly, from the same university, we have a study that shows that men don't respond to low grades in introductory STEM courses as much as women do. So women tend to get more discouraged in early failures in STEM. And so we want to make sure that we are catching the early coursework for also this reason. Introductory coursework at this university, because it's the core, has common syllabi, common learning objectives, same exams and assignments, and common grading. And so that allows us to be able to compare across sections. And as I said before, it eliminates student selection issues. And so for these three reasons, it's kind of the ideal closest situation to a laboratory where you're randomly assigning students to different sections and looking at how their performance differs both across faculty as well as the student gender. So let me actually show you some evidence of the success of this random student instructor assignment. The way it works is that the registrar assigns students randomly to sections. It's actually quasi-random because they try to balance the percentage of women in each section, but based on that, it is random. And then randomly assigns faculty to those sections. And so to convince you of that random assignment, I have here plotted student gender and instructor gender 2 by 2, and how the SAT math scores on the left and SAT verbal scores on the right are distributed. And you can see that there is no difference between the students who get female instructors versus male instructors. We're going to supplement this data with a survey of current students. So recall that our data period ended in 2017. We're going to survey them in 2019, the current students. And we're going to ask them their initial expectations of getting an A. We're going to call this a performance expectation. How excited or interested they were about the course at the beginning, and how much effort did they put in. In the next page, we ask how they felt that they were treated by a professor and how much the professor was a source of inspiration or a role model for the student. And at the end, we ask GPD expectations that we incentivize for accuracy based on historical data. And we ask them why they expect that. And so I'll show you these expectations in a little bit. And finally, we ask them to rate each course on perceived quantitativeness, 0 being not quantitative at all, 100 being the most quantitative. And all I want to show you from this perceived quantitativeness courses is it aligns with our expectations that finance, stats, operations, accounting, economics are rated as quant classes. And organizational behavior, marketing, business law, and strategy are the POET classes. Now, this quant group may disagree with that perception, but remember that this is an introductory course in an undergraduate level. And so the students are perceiving marketing to be much more POET than quant. Let me pause here to see if there are any questions.
Hey, Shima, Upendra here. Just a broad question. So I know that you're looking at gender-related stereotypes and stuff like that, but I'm just wondering, are there other stereotypes also known to be relevant in this context? More from the point of view of what else could be studied here. That was my broad thought. Like,
yeah, no, it's a great question. In fact, the main point of me presenting this research today is to inspire people to study this question in different ways. So thank you for that question, Upendra. I think ethnicity is an obvious one. And we could not, the fact that we could not study it is because of the lack of variation on the instructor side, which in itself tells you how big of a problem this is. So there are a lot of things to study in this context. I would recommend, if you have a more racially diverse faculty, to look into that.
Yeah.
Hey,
I guess just a follow-up question. I mean, is there something known about these issues already, or is this something not studied at all?
Oh, so in the interest of time, I cut out the literature review slide. There is a ton done on these issues in high school, and some in STEM. Most of them are correlational. The paper is on my website. I can point you to some of the causational, a handful of the causational ones. There's only one paper looking at ethnicity, and they do find, I believe it's in the high school context, high school math education context, a positive effect of ethnicity match.
Yes, thanks.
Yep.
Hi, I have a question basically about the mix of students, the gender mix of the students in the class. Because I was just thinking, like, the explanation that you seem to be pointing to is that the female instructor, right? So then the female students probably find that's a role model, easier to interact with, and they have evidence this instructor is successful, I can do that too. But suppose like you have more female students taking a quant class compared to some female student, not a quant class, very few female students for some reason choose that path. So basically you can think about it, I can also have a large kind of, peer group that I feel comfortable interacting with. I don't know whether group assignment or this discussion is an important component in those classes. And also, I'm just thinking about why sometimes female students feel very dreadful going to CS class, because they say, I can't think about any of my, seniors getting an A from that class. So I'm just thinking like, I think it's a combination of stereotyping and also maybe a role model like I can find for my peer group, or maybe easier communication.
Yeah, so great question. So I think what I want to preface this talk is by saying role models don't have to come from faculty. In our empirical context, our hope is to provide causal evidence for this mechanism. And what we have is a random assignment of instructors. We do not have a situation where the percentage of women are changing across sections. It is kept constant. And because these are mandatory classes, there is no selection. So we don't have the variation of female representation in the class. So we are shutting down that path in our empirical analysis. That does not mean it doesn't matter. So, and in fact, peer groups are shown to matter in field experimental settings. For example, in economics, when group work is varied, the composition of the group in terms of how many women are there is varied. It seems to have significant effects. There's a job market paper from University of Zurich this year. If you're interested, I'm happy to send it to you.
Okay, thank you.
Thank you. So what we're going to do is first document GPD, just the main effect, controlling for student background, student S in class C, instructor P for professor, semester T for time, and controlling for their background characteristics, course term fixed effects. What is the impact of being a woman? We're going to cluster the errors at the course instructor level. What we're going to find is negative means women do worse than identical men. Positive means men do worse than identical women. Overall, women are most disadvantaged in finance, followed by business econ, accounting, so forth, and men are most disadvantaged in organizational behavior, marketing, business law, and so forth. Let's summarize this. Quant, non-quant is about 11% of a standard deviation in grades for women in quant, and 23% of a deviation in grades of men in non-quant classes. Now, I don't want you to think of this as a bias. It could come very much from beliefs or preferences itself. So we asked for the beliefs, and in the survey, students of both genders expected men to do better in quant classes. And this could be completely rational expectations as well, right? Or it could be self-fulfilling, inaccurate expectations. We don't know. The reasons we asked them why, the reasons they gave are, could be classified into 3 buckets. They sometimes said stereotypical things like men are better at math. And even women could say things like women are better in soft skills. There were also reasons that were related to differences in career interests. For example, some of the reasons were, well, men want to go into finance, so they put more effort into that. We don't know if that's an innate preference or from other expectations. And then about 16% of people said lack of representation at the top. Now, this is thinking about business students at large and trying to predict how they perform. Thinking about themselves, again, women expect to perform worse in quant classes. Men don't have any differences. They're equally confident about quant, non-quant. But men are much more interested in quant courses and women are much more interested in poet courses. So there seems to be an interest difference as well. So is this innate or is this malleable? That's the big question that we had going into this. And just to remind you, the potential mechanisms are, these are innate differences. You can't really move them around versus some sort of, there might be some stereotypical beliefs that could be moved by role models. And going back to Ying's question, these role models can come from anywhere. What we have in this empirical application is this exogenous assignment of instructors. So what we're going to do is we're going to just interact the student gender with instructor gender. But importantly, we're going to be controlling for student gender, course, term, fixed effects. What that's going to do for us is it's going to control for the general achievement that we would expect from a female versus a male student in that course, regardless of the gender of the instructor that's assigned to that particular section. And this is important, again, to control for the potential aggregation bias, because it is the case that finance courses have far fewer women teaching them than organizational behavior courses. In poet courses, it's about 50-50 gender split on the instructor side. In quant courses, it's about 15%. And so if you aggregate it across these treatments without thinking about the fact that generally women in quant courses may do worse, and therefore there are fewer instructors also teaching those courses, then you're going to be biasing the effects. So allowing for student gender specific course term fixed effects takes care of that. We put instructor observables, student observables. Student characteristics are, again, I didn't mention this, but they vary by type of course. So the impact of your SAT math score on a finance course is different than the SAT math score on a marketing course, which I think makes sense in this context. And we allow for the instructor controls to vary by the student gender to allow for a fully interactive model. What we find is that the gender of the faculty member matters, but only for women in quant courses. So this gamma for the quantitative courses says that the gap that was about 11% is closed by almost 8%, not fully, but almost there, if the students are taught by a female professor. Now, perhaps, you know, unfortunately, I must say, the instructor gender has no effect on the discrepancy between men and women in non-quantitative courses. And I'm going to discuss that in a little bit, but let me show you further evidence. If we look at the survey data, as you can see, this is the first column is from the administrative data. If we turn around and look at the survey data, we're going to see that the interest of women in a course is higher when they're taught by female professors. Their performance expectations are also higher when they're taught by female professors. There's no effect on the effort. And again, we don't have much of an impact on the male students in poet classes. So we also wanted to look at where is this coming from. So we divided the students into having low, middle, or high math aptitude based on their SAT and ACT scores. And it is the women with the middle to high math aptitude whose performance in quant classes is lifted when they are treated by a female faculty member. So that brings us to the question of, could this be explained by instructor bias? Is it that the students, I mean, some of this data, let me go back actually, some of this data already suggests that if the student interest is affected and performance expectations are affected, something else is happening on the student side. But we want to also think about, you know, could it be that female instructors either curry favors to female students, or on the flip side of the coin, male instructors, you know, inadvertently or explicitly, you know, have a bias against female students in the quant courses. We're going to suggest this doesn't seem to be going on, and we have three pieces of evidence for this. The first is that students report a positive role model effect, but only if they are female students in quant and being taught by female professors. So the mechanism that we are suggesting is happening seems to be reflected in the survey data directly. In addition, it seems that the perceived treatment, when we ask students, hey, did you feel you were fairly treated by the professor? That doesn't vary by the instructor gender in any type of course. So of course, that doesn't rule out implicit bias, although it does say that if there were a bias, it wasn't felt by the students. Now, coming back to this implicit bias idea, we also wonder, well, perhaps students don't feel it, but it might be going on. How could we potentially detect this? Well, you would think that when, if it's instructor bias, it would be bigger in instances where the instructor has more direct control over a student's grade. And when does that happen? Either when the instructor is grading them directly and or, in fact, and the grading is subjective. So where do we see this? We hand-coded the syllabi of all these classes across the 15 years. And here what you see is the percentage of the grade of each component, graded component, for the final grade. So on average, class participation accounts for 10%, but in some courses, in some terms, you know, it could be as low as 0, as high as 25. We also coded individual versus group work components. And the idea here was that outside of class participation, all of the individual-based components are either graded by TAs or standardized. So the room for subjectivity is much lower. And the group-based components, in contrast, are mostly assignments during the term that are done as a team. First, the team dynamics, the gender dynamics might be quite different. Second, the professor is more likely to be grading those bigger team projects herself or himself. So we wanted to see if any of these components had any effect on the interaction we were finding. So we're going to extend the female student, female instructor interaction further by a third level interaction of these components. And what I'm showing you is that that main interaction remains significant. None of the third degree interactions are significant. This doesn't rule out, but it is, because null effects don't rule out anything, but it suggests that we are unable to find a story that is suggestive of instructor bias. So at least the effect that we are documenting seems to be mostly driven by the student side.
Sorry for interruption. You have 10 minutes.
Thank you. So what to tell your dean, what to take away from this study? We know from previous research that early intervention can matter. Early grades can determine academic paths, which then determine career paths. So it's important to look at introductory courses. And it's important to think about the challenges students have if they don't do well in those introductory courses. The sad news is that women tend to not do so well in quant courses, and men tend not to do so well compared to what their academic background indicates in poet courses. The good news is that women's performance in quant classes is malleable and responds to instructor gender. Now, again, to Ing's point earlier, this doesn't mean put a bunch of female instructors to teach these courses. It just means that role models matter. And in our study, we had exogenous variation in these role models. That doesn't mean that other role models are not effective, less effective. They should be studied. In fact, they should be employed. It seems that, the fact that role models help, we only want to show it as evidence that stereotypical beliefs may be at work here. And then we have a full gamut of ways to combat those beliefs from extant literatures that we should be experimenting with in the business schools.
I have a quick question, Yesim.
Yes.
Yeah. So talking about role models, do you think then in top administrative position, having more females or whatever group it is, that might be helpful? Because in some sense that might be easier to do, because we cannot change the percentage of female faculty overnight, but I think we can easily change the percentage of female deans much faster.
Yeah, I am not sure that, so every bit helps. However, I am not sure that having more women in general is going to help, precisely because in this university we're studying, it's about half female-male student ratio. We had female deans and they haven't changed. So it's not having more visible women around, but I think it's particularly having successful women in these types of careers as role models, right? And thank you for clarifying that. And the one glaring null effect here is that we cannot change, in other words, the male faculty, having a male faculty in marketing hasn't increased the performance of male students in marketing. So what do we do about even the bigger GDP on the poet side? So we need to go back and ask, why hasn't this had an effect? There could be two potential explanations, and we can't rule this out in this paper. One, men have an innate preference for quant areas, and no matter what the context is, that's the preference they're going to follow, and let's not even try to change it because it's welfare maximizing. The second opportunity is they may also be suffering from stereotypical biases, but placing a male instructor doesn't combat these biases. I think this is quite plausible, actually, because recall that in quant subjects, it's a rarity to have a female professor. So when you have a female professor, that's a really strong counterexample to the stereotype. Whereas it's pretty common, it's about 50-50. It's very common to have a male professor in poet classes. So perhaps that's not enough to move a stereotype. So we can't speak to this, but I want the audience to know, you know, let's not just focus on the female side. There's a huge gap on the male side as well. So finally, I think the reason for hope part is that the role model, to Tanjim's point, role models matter, but I think, thank you for Tanjim clarifying that nuance. I think it has to be the role model in the particular field, not just more women around. Now, I do want to caution everyone before you run to your dean and say, let's put all the women to teach quant classes. You know, a lot of, we have a higher percentage of female faculty in junior ranks. And we know that there are biases that also female faculty face in the classroom with student evaluations and so on. So I do want to caution you that the punchline of the paper isn't let's put more women in these situations where it may not be beneficial for them, but let's collectively try to think about these stereotypes and how the business school is in a good position to combat them. Different role models could include, like I said, alumni or businesswomen. Those are all the comments I have. I would love to open it up for any questions you may have at this moment. If there are none, then I will pass it on to my discussant. Thank you all.
Hello. Can everyone hear me?
Yes.
Yes. Yes.
Great. Can you guys see the slides?
Yes.
Yes.
Great. Thank you. Thank you for the presentation. My name is Shervin Li. I'm an assistant professor in marketing at LSE. And first, I would like to thank the committee for the great opportunity to read and discuss this paper. I have to say this is one of the papers that I find myself can really relate. The first half of the paper reminded me of my experience as a student at business school. And when I read the second half of the paper, I was just so eager to know my role as a faculty member and what can I do. So let me first summarize the research question and the contribution. This paper examines a very substantial question, gender performance difference, or say GPD, in academic performance at business schools. First, this paper differentiates from the previous literature examining the academic performance of students in both age group and discipline, as in it focuses on university education and in business schools, where we train our talent for business field. So therefore, it also gets closer to the salary inequity issues the presenter brought up in management jobs. Other than empirically documenting the GPD, the paper further examined the causal impact of instructor gender in attenuating GPD. It provides a very important policy suggestion for business schools. As we all know, in business schools, we have long been focusing on improving gender proportions in our recruitment processes. And this paper provided another facet and impact on this, the instructor gender effect in GPD. This is one of the things I really appreciate from the paper. And to do this, the paper utilized multiple data sets and the structure of the curriculums in their empirical models. I'll just quickly summarize it. So first of all, it is not easy to examine the role of business school education, especially the role of the instructor genders in students' academic performance. So first, before business schools, for one, students could be different. So the paper controlled student background and their grades using, before they joining the business schools, using their university application information and admin database. For 2, the students could select themselves into different courses, and for various reasons, including both the abilities and the preferences. So what the paper did is to focus on the fixed core curriculums to get a random assignment. And moving on, during the time in business schools, the instructors could also be different. They could be different in abilities, course designs, student experiences, class interactions, so on and so forth. So what the paper does is it controls for the above factors using admin database and detailed course syllabus. So after their business school experience, academic measures could also be different. So the paper, this paper controls it using the admin database. And then eventually, a survey on the current cohort is used to pin down the mechanisms. So together, this paper utilizes 3 datasets, including the 15 student cohorts, plus 1 survey for the current cohort in their framework. As to findings, first, gender difference exists before enrollment. And 2, there is systematic GPD existing after the business training in business schools. And then eventually, they proposed ways to attenuate this effect and explored different possible mechanisms. So the presentation was actually great and very clear, and it actually also clarified some of my previous questions. So I will just want to bring up several points or say several questions that I found myself curious about. I have to say that some of the questions might not be the focus of this paper. It is just I, as audience, am really curious about those questions, especially since the authors actually have done an excellent job in providing all of those detailed information in this paper. The first thing I find astonishing is what has happened in the 1 to 2 years of business school training. I did a quick and rough calculation based on table 1 before students join business schools, because I just simply divided the difference by mean. The GPD was around 2.5% to 4.7% in quantitative tests, depending on which test we use as benchmark. And it was minus 6.7% to minus 1.4% if we exclude the non-significant results in those non-quantitative tests. Now see what happened. After business school, if we purely look at numbers, they enlarged a lot. Although from the survey, we actually learned the female students actually input significantly more effort into both quantitative and non-quantitative courses, at least for the current cohort reflected from that survey. But it's not a fair comparison, nor suggests any causal relationship in this sense for what business schools have done to our students. One thing is, I just simply divided the difference by mean. And the other thing is, even if that is the case, there could be several reasons. It might be the different measures in academic performance before and after joining business school. The system completely changed. It could be the different quantitative levels, or it could be the GPD was actually enlarged. Well, it doesn't impact the results of this paper at all. I just think it might also be interesting to see which one is the case and what was the reason. And when we look at the female faculty members in quantitative courses compared to other cases, the effect difference was 7.7%. So I was just wondering what was the total effect in each cases, and if we can report that. Does this sorting effect in this paper also exist when we look at each case? The next thing I want to say is I find it might be interesting to also look at the self-selection itself. I have to say that I appreciate the study carefully designed in a random assignment framework, and I totally agree this is the way to go to examine this question. But here I brought up this is because I was just wondering, it might also be interesting to take a look at the self-selection courses So the choice or the participation itself, especially when the students have systematic different expectations and beliefs on different courses. And by the way, I believe they can see the gender of the faculty members before they decide to join a class. If that is the case, did this expectation eventually translate into their choices? And when there is a gender match, does this change their choices? Or at least is there any correlations going on? I'm just curious about that. Another thing I'm very curious is that, so in this paper, there are 15 years of data. So is there any observational pattern suggesting changes from the data? From the model perspective, no clear change would be better for combining these 3 data sets with one survey data in examining its causal relationship from the current cohort. But of course, from the community perspective, we hope there were improvements. And by the way, even if there is a clear pattern, I think the past course evaluations might be a little bit useful and supplemental to the survey in that case. The next thing I want to discuss a little bit is the course structure. I actually paid attention to the presentation and I went back to the paper a little bit. I think I agree the group conversation part is very clear and it suggests that the effect mainly comes from the student side. But I think one of the interesting results is the group project proportions actually doesn't have a significant effect. Because for that, you would think, before you see the result, you would think that it might partially indicate the likelihood of teamwork and the learning opportunities for both the female students and the male students in each type of the courses, provided the group compositions is observational. And when we don't find a significant effect, and this factor actually doesn't matter, I think that partially answers Ying's question on whether they learned from the from the students, the conversations, whether that's a communication route. It doesn't really completely answer Ying's question, but I think this is a little bit correlated. As you can see, I really relate a lot to this paper. And one fact I find super interesting is the systematic pattern in the students' belief. The mechanism in this paper in communication and the signaling actually reminds me of this paper, Jensen 2010. I believe it's a NBER working paper. It has a field experiments in several regions in India on purely changing the belief of the job opportunities of a female that can actually change their parents' investment in girls' education. So as a very important contribution or implication of this paper actually tells us that changing female students' belief through this kind of implicit communication or say signaling process could also help with GPD. It just reminded me of that paper. I feel related to that. At last, I want to thank the authors to include very detailed information in this paper, not only the key variables or settings for their empirical models, but also a lot of institutional details and a lot of interesting observations, patterns, findings. And by reading the paper, I really learned a lot on business school trainings and the student's journey, which I haven't done in the past. So as a clear result, I become very greedy to see all of my curiosities got answered in one paper. So that's all I have. And finally, thank you again for this opportunity to discuss this paper. I enjoyed reading it. And thank you again for your time.
Thank you so much for your comments. If I may take a few minutes, since we have a few minutes of time, to answer some of the wonderful questions you raised. This brings me so much joy because indeed we would like to present this paper across a wide variety of audiences because it evokes this curiosity, and some of which we cannot answer, but we hope that others will. So I'm happy. So you asked about the evidence of change. We did look into this, and I was hopeful. We did not find much. So that's a letdown, but that means whatever progress there was has been made prior to the last 15 years. One would hope we can make more going forward. You asked about past course evaluations, and we did include controls in a different specification of course evaluations, ratings of professors. It didn't budge the results, but it might be interesting to go back and look at it as kind of an outcome variable rather than a control variable. You asked about, well, group projects didn't matter. They didn't matter in the extent to which female professors impacted female students' grades. That doesn't mean that the GPD didn't vary by whether there was a group project or not. I actually don't recall at the moment. I will have to go back and check. One reason we may not expect it to matter in this context is because in the last 8 years, the business school has resorted to this external and exogenous group assignment where they're trying to make sure there isn't the lone woman in the group. And so any effects that you might have seen might be erased by the conscious efforts of the business school. So this is actually something to look into for other institutions. If you have data, endogenous, exogenous assignment, I think is a fascinating topic. The peer interactions is a very important, fascinating topic. And then finally, you asked about, could we see the impact of women in each case? If I understand that question correctly, are you asking for the impact of female faculty across different types of courses? If that's the case, we have a lengthy appendix in which we report that, but maybe you were talking about something else. I wasn't sure.
No, by total effect, I just meant if we look at the business school as a package, just simply divided into different cases, just to look at the total effect from beginning to the end. What is the effect?
Yeah, thank you. That's a good point. I had never thought about comparing GPD coming in versus going out. As you suggest, there are some downsides, different measures and so on, but it was an enlightening discussion. Thank you very much for your comments.
Oh, those answers are great. Thank you very much. And then I think finished earlier.
I had a quick question. Yeah, I had a quick question for Yesim.
Sure.
Just again, this is more of the curiosity category. Are you thinking about, because you have, I think, cohort level information, mapping these to placement outcomes?
Yeah, so we were able to get placement outcomes for the last 3 years from the alumni office, which doesn't give us a lot of overlap with the 15 years cohort. We did try going to LinkedIn. The problem is because of the sensitivity of the data, we cannot see the student names. So we don't have any way of matching one-to-one. It would be wonderful. The paper reports some of the placement descriptive statistics in the discussion if you're interested. We do see gender differences in graduating salaries and types of careers they self-select into. So what I opened up with, based on the recruiters lamenting, there is some bite there, but we can't map them.
Thank you.
Yeah. Any other questions?
Hi, can you hear me?
Yes.
Yeah. Hey, first of all, congratulations on excellent piece of research. Awesome. One of the things that you may have had the data or not had the data is, relating to the placement. Also the salary differences, if there's anything that you could look at, before doing the program. And this is all undergrad, or is it? Yeah. Okay.
This is all undergrad. Yeah.
Okay. Okay. All right. So, is there anything that you could study on that differences too?
Yeah, so like my answer to Upinder, we have some salary information, but we cannot match it to these individuals. We do show gender differences in salaries, And those, one thing I forgot to say, those gender differences in salaries are completely explained away by industry and career choices. So we replicate some of this intuition that came from Bertrand et al. In an MBA setting, also in the undergraduate setting, but we don't have much more than that.
Okay, that'd be awesome. But this is an awesome study. Thank you.
Thank you. And this is my call for everyone on this call. Go to your deans, request data. There's so much more to be done. So thank you all for your attention and hope to see you in other seminars today.
Thank you.
Thank you.
Thanks.